Hey guys, welcome to this session by Intellipaat. The Internet of Things is a network of responsive devices and everyday objects that are connected via the Internet. They are embedded with sensors that enable them to collect and exchange data without human intervention. The IoT will keep companies informed about everything from how customers are using products to when a piece of vital equipment needs replacing. Wondering how to harness the power of IoT? We'll tell you how in this full course video on IoT presented by us. Subscribe to our channel and hit the bell icon so that you will never miss an update from us. Now let's look at the agenda before moving on with this session. So first we'll start off with the introduction to the Internet of Things. Then we'll move on to the architecture of IoT. Then we'll learn about sensor devices and how they work. And once we learn all this, we'll move on to a hands-on where we'll be looking into a water quality monitoring project. After that, we'll look into Arduino IDE and its code basics. Once we learn Arduino, we'll also learn Raspberry Pi and how to assemble the Pi. Finally, we'll look into Netduino and general gear. So these are the topics which are covered in this video. Now, without any further delay, let's get started.
To start out with, let me ask you this. Did you know that by the time you pretty much read everything on your screen right now, by the time you saw the tiny animation, there are 4,000 new devices which connected to the internet just now. So all in total, there are 50 billion devices that are connected to the internet worldwide today. And in the internet rush era, everyone wants to get into the internet today, right? So be it, attaining new information, be it into using your internet as a marketplace, as an entertainment place, so if you want any new information, you're reading something, you want to learn something, master your new IT skills, for example, you will come to the internet. And then if you want to sell something, if you want to become an e-retailer or anything like that, you will come to the internet as well. And then if you're looking for some entertainment, be it Netflix or any other music source, TV watching source, or whatever it is, you will come to the internet. So you realize that we can actually validate why 50 billion devices across the world are actually connected to the internet today. And on that note, if these many devices are connected to the internet, how best can one make use of it? And this brings us to the quick introduction to IoT. When we talk about IoT, the first thing we need to discuss is what is IoT? Well, IoT is basically an interconnected web of objects, and these objects in our case are called as things, hence Internet of Things. So basically these things, the objects that we talk about, are guided with sensors, they have software present, they have a lot of hardware, and all of these combine together to achieve one single purpose, to achieve one single goal. So there are multiple goals of IoT, and we'll be covering in the next part of the session as well. So whenever you think of Internet of Things, whenever you think of anything IoT, the first thing that might come into your mind is all the hardware and the software which works in coordination to make it work. So why do we require IoT in today's world? We have 50 billion devices connected to the web. So in today's world, we need to understand that with these many devices connected, there is a lot of data being generated, right? So there's zettabytes, there's petabytes, and whatever is the new term for 10 power x, where x can be 15, 20. So when this much amount of data is being generated every day, we understand that by using data science, we can make use of these data to drive our capability better to take nicer decisions, to take decisions which will help in the short term and the long term as well. So with respect to IoT, with IoT we have more data, and now we can club it in with the right software and the hardware to make better decisions. So the next thing is smart healthcare. With respect to IoT, when we talk about smart healthcare, it's all about your well-being to the best, where you can use the latest bit of hardware and software which is available to you to probably let your doctors know, to let your physicians know about your current health conditions, current well-being and whatnot, even if they're not physically present with you. And all you need to do is have these devices at hand and ensure that you have an active internet connection, and you will have the access to the entire world of smart healthcare. And the next thing is convenience and automation. So with respect to IoT, you can change all the mundane tasks done by humans and basically make everything smart and convenient for the people. So what this does is this ensures that your workforce, your population will basically put in their time and efforts to the tasks that are more productive, that are more qualitative, and at the end of the day which drive more insights to your business. And of course, if you have smart wearable technology, if you're building smart cities, if you have a smart home and everything smart at the end of the day, it increases the quality of your life totally, right? So you can open your door by sitting at your office by the click of a button on your phone. For example, if you have guests at home. So most of the time it so happens that we're at work and there's a delivery package at our home, and 90% of the time either we leave it with our neighbors or we ask for a next day delivery. Well, with the use of IoT, you can actually ensure that you can have a small separate box which opens at your command, and at the end of the day you can have these parcels and packets sent into that box, and then you can later lock it remotely and whatnot. Well, the one thing you need to know about IoT is that the absolute endless hunt for making things smart. Everything from smartwatches, as I just mentioned, to smart shoes, to basically anything you can think of. So it can be a smart health tracker, whatever it is. If it is associated with the word smart, there is a 70% probability that it includes something to do with the Internet of Technology. So now coming to IoT as a career, well, these are among the 4 most important reasons of why you should consider IoT to be your career. The first thing is that it is among the top 10 jobs in the entirety of this decade. It was in the top 10 jobs for the last decade, and it has been projected it's going to remain in a higher spot at this decade as well. So make sure to check out the Intellipaat's video on the top 10 jobs for this decade to know more about this. Now coming to business requirements, in today's world everyone wants their problems to be solved at the quickest. With respect to IoT, there is this demand and supply created where the demand is high while the supply is less, and just for this one particular reason, if you jump on the IoT train, you can make a very good career out of it. And of course, we live in the mobile era, right? So for 80% of our tasks during the entirety of the day, we look at our mobiles for it. Be it browsing the internet, be it ordering food, be it getting into a meeting, whatever it is. So we are in the mobile era. So we are a generation of mobile users who are basically achieving goals and feats which could have not been done probably 10 years before now, and even 20 years ago. This would have just been fiction, right? And of course, another important reason is that IoT is a one-stop solution to everything. Be it recycling, be it green energy, be it your health monitoring, be it smart cycles, be it your working environment being smart, be it power saving, whatever it is. So we can go on and name unlimited number of applications on why IoT should be a very good career path for you guys. And of course, at the end of the day, it is an amazing career path. And then when we have to talk about how IoT actually works, well, IoT works on 5 main principal components. One, it's the hardware. Hardware consists of all of the sensors, the actuators, and everything which form the actual devices, the part of the sensing layer, which we'll just check out in the architecture. And then comes the software. When we have to talk about software, you will be writing custom code and custom programming concepts where you'll be helping this hardware talk to the internet. And of course, if you have to make a software talk to the internet, you actually need access to the internet. And this is where there's the protocol layer where you'll be actually making your software and hardware connect to each other via the internet. And then when you think about it, when you're on the internet, you need some security. So defining security protocols to ensure that your softwares, your hardwares, and in fact the entirety of your IoT device is safe, the security protocols are very much important. And then of course, after all of this is done, your device is ready. Now you need a way to control this. To control all of this, you can make use of your computer, you can make use of your mobile, and at the end of the day, anything that's connected to the internet can have access to this. So here is where you'll have your application, here is where you'll have your dashboard, here is where basically you'll have the controlling entity to go on, make changes, use your IoT device and everything else. So if we have to talk about the IoT stack, the first thing that we need to talk about is when we say Internet of Things, the thing is basically the goal object. So this thing is the entity, is the asset that we want to control. It can be the device which we want to monitor as well. So to do this, we understand the first step is to have a thing. So after we get the thing that we want to control and monitor, we need to provide it with some data. So in the data acquisition stage, we ensure that we get a signal and we make the software talk to the hardware by converting the software from an analogous format, which is basically the result of the input and the outputs of the hardware, and convert all of this into a digital format. After the data has been converted into a digital format and read by the software, well, to combine and use this software with data present everywhere, you need to have access to data processing methodologies. With respect to data processing methodologies, you have data analytics, data data processing techniques, and of course, if you've analyzed data, if you've processed data, you need a place to store it. There comes data storage. And of course, at the end of it, you need a communication module where your devices can either communicate on a local network or they can communicate via a cloud network or any other third-party network communication systems as well. So the stack begins by having a goal thing, then we have the data acquisition. After acquiring the data, we perform data processing, and after data processing, we have the communication module where your IoT device can talk to a network stack all in all. And of course, if you're talking about IoT device management, we have four important things we need to cover. There's notifications, security updates, data reports, and data updates as well. With respect to notifications, every time there is a change in your IoT device, every time there is a change in the network or the behavior of your device, the user or the person who's programming it must have a notification. And of course, security updates are something very important because your devices will be connected to a network. When it's connected to a network and especially to the internet, people with malign intent are present everywhere. To make sure that your device does not succumb to this, we need to provide security updates as well. And of course, data reports are a process of either debugging your IoT devices or ensuring that it is a goal. For example, if you are wearing a smart watch, so getting the data reports is the goal. What is the number of kilometers that you have run? What is the GPS position of you when you were running? What was the inclination? Probably what was your heartbeat, and much more, right? So these data reports can be the goals in most of the cases, which is very important. And then we have the general data updates where every second your IoT device has to have an interval where it keeps shuffling through the data and it keeps generating new information based on this data. Let's consider the run example again. Let's say you're running around a track, and now do you want the data to be collected every single second? Do you want the data to be collected and analyzed every 10 seconds, 20 seconds? Right. So you get the picture. This is where you set an interval of data updates where these updates are taken in by IoT devices, processing is done, and later the data is pushed to the dashboard as well. So how does data communicate when you talk about IoT? The data movement in any IoT devices is basically based on these six concepts: Wi-Fi, Bluetooth, cellular mobile internet, and then we have the RFID, which is basically the radio frequency identification. Then we have NFC, which is near field communication, and the radio frequency tower communications as well. So basically these six are different protocols all in all together, where some are near field communication devices and some are far field where they do have a particular range. For example, Wi-Fi will have a greater range than Bluetooth, and you will get a cellular connection in most of the places today because there are cell towers everywhere, there are RF towers, and with NFC, for example, your devices have to be in close companion together to basically achieve this sort of communication. And then you have RFID readers as well. So when you think about the ways your IoT device can communicate, the way you can program your IoT device to communicate well. So as you can see on your screen, there are six major protocols that you can work with, and with the combination of all of these, your IoT device can become extremely powerful. And of course, what are the interactions that goes on in the world of IoT? So the first thing is basically people-to-people interaction, where a couple of people are sitting together, deciding on the goal, deciding on what needs to be done, what is the task at hand, what is the problem at hand, and how they can solve it. And after this is done, people to computer interaction happens, where a person is an IoT developer and he's programming the hardware to basically talk to the software. There will be another software engineer who will collaborate with this hardware programmer. So at the end of the day, your people computer interaction is all about making your IoT device ready and be ready to connect to the internet. And of course, after that is done comes the machine and the data interaction. With respect to machine and the data interaction, your IoT device or your programming arena must have the capability of processing data, pre-processing data, analyzing data, and even storing data. So after all of this is done, there comes your data machine interaction, where your data is fed into your IoT device. And for example, it might not be data being fed into IoT device as well. It can be the data from the IoT device where it's reporting and generating data for you too. So as you can see, the four main important interactions that take place in the world of IoT is key in understanding how one can go from the first stage of generating a plan, creating a device, all the way till ensuring that your data and your machine can talk to each other. When we're talking about, again, Internet of Things, the word internet will grab a lot of attention, especially with respect to privacy, especially with respect to how it can be secure. So there are three main things when you talk about IoT security measures. And the first thing is you should be writing a program, you should be making your device to be practically impenetrable. So if this is the case, no one will have access to your device who is unauthorized and someone who has malign intents for it. And after that, ensuring that your data is secure ensuring that your data input, your data parameters, and everything corresponding to that whenever you're working with your IoT device is secure. This will basically form the entire foundation of ensuring that your IoT protocol, your IoT network is safe. And then in this evolving world that we live in, as fast as good things evolve, well, people with bad intentions also update at the same time. So it's key, it's one of the most important things in the world of IoT to basically keep the softwares to the late. So to basically provide on-time updates, to stay 1 step, 2 steps, 10 steps ahead of all of these people with negative intentions. With that, we can take a quick look at the IoT architecture. There are 4 important layers when you're working with IoT, and we can begin from the bottom-up approach. In the first layer, we have the sensing layer. Sensing layer is where you actually have your actuators, you have your sensors, and you have your entities which can actually sense something. For example, you might have a gas leakage detector, you might have a light sensor, you might have a camera which can pick up motion, and you can have an entity which can sense temperature around you, and all of these. So you're getting the point here. And even a heartbeat sensor. I hope you're getting the point in the sensing layer. So all of these sensing layers have one specific task that they can do. Now, to make these talk to other layers of the task, you need one important layer, which is the second layer. It's the network layer. As we discussed in the protocol section, it might be via Bluetooth, it might be via Wi-Fi, it might be via communications of near field as well, be it RFID, be it NFC, and even cellular mobile internet. So once you make your sensing layers talk to these communication protocol, these communications protocols will basically connect your sensing layer to the data processing layer. In the data processing layer, it's considered to be so the data processing layer is considered to be the heart of an IoT device, because it will take all the information from these sensing devices, and it will process this by making use of a CPU, by making use of a graphical processing unit, be it a tensor processing unit, and be it a niche specific unit which can analyze your sensors. So this, in coordination with the network layer, will ensure that your sensor layer is working fine. It can be So the data processing layer also has the ability to debug your sensing layer. It has the ability to work with and update your sensing layer software and much more. Coming to the application layer is basically the usage of everything that's been done in the previous 3 layers. Now, be it taking your data to the cloud, creating a dashboard, creating an API key where you can use this somewhere, or creating a portable smart watch where you can access all of these data through the watch as well. Now, we've seen the feat of smartwatches in today's world. The watch, there are top providers of this, and these are some of the most classic examples of where IoT can be put into full use. Be it your smartwatches, be it anything else which can be a safety hazard issue. For example, taking your data to the clouds, monitoring your programs from anywhere across the world, having connectivity to all of your IoT apps at an instant on your mobile phones. And these form a very, very important aspect of the application layer, because at the end of the day, all the backend is controlled by the below 3 layers, and the application layer is the front end where you will be in constant interaction with your IoT device. So to add to that, so what are some of the top applications of IoT? When you can think about IoT, again, head to the comment section at this particular point of the video to let us know what your thoughts are and where you think IoT is completely fit for, where it's a staunch requirement in today's world as well. Coming to the first most important application of IoT, I think it's in the field of agriculture. So in today's world of agriculture, we can provide everything to the farmers that they need to basically step up their game in producing crops as well. So it can be water monitoring systems, it can be soil parameter monitoring systems, it can be automated systems of cultivating crops or whatever it is. So keeping the agricultural sector updated, so keeping the agricultural sector connected to the rest of the world via the internet, and ensuring that they get everything that they require to create smart products and putting these smart products to use. Well, that's everything about IoT, and of course with respect to agriculture, without which none of us can survive, without which we cannot be here right now. So this forms to be the number 1 application, in my opinion, of IoT. Coming to the second important application of IoT, it's in healthcare. Of course, again, just as important as agriculture, just as important as crops, health is the next best thing. So health is the thing which takes priority over everything else, right? So consider this situation. Let's say you are away from your doctor, but you do have access to the internet. In the future sense, you can pop a tiny pill, and this pill will basically have a trans receiver which can talk to your your mobile device, which is connected to the IoT, so which is connected to the network layer, and through which your doctor can check out certain aspects, certain parameters of what's happening with your body through the pill that you just ate. Your physician might be thousands of miles away from you, and it wouldn't matter because it would be 90% similar in a situation where the physician would be right next to you as well. Of course, in the world of healthcare, IoT is booming and IoT is being put to use every single day. There are new aspects, there are new items, and when you think about it, there are new prospects which are generated with respect to healthcare every single day. So I was reading about performance enhancements where IoT is being implemented, where you could think about heart monitoring systems, which are not these hefty devices that you wear, but pretty much a single pill that you can swallow again. So when you think about healthcare, the number of applications, the number of devices that one can think of and one can create in the near future is exemplary. So coming to the next most important application of IoT, it's smart homes. Well, I personally make use of a smart home with a lot of IoT devices connected. For example, if it's my house lighting, it's automated. The outdoor lighting is automated. My aquarium lighting systems are automated. And we do have a baby monitor at the house as well. So when you think about it, you can do a lot of things. Everything from keeping your door lock to be smart, ensuring the GPS location of everyone in the house. You can have a thermostat to automatically control the temperature. You can have automated lighting, as I just mentioned, automated camera tracking. You can have a smart lawn which can water itself whenever it feels like it is dry enough so that it requires water. You can have an automated smart cooktop which can control the temperature, be it live tracking of all of your vehicles and parcels or whatever it is. And of course, in today's world where water is a strong requirement, you can ensure you can put smart devices under your water taps where you can continuously track and monitor water usage as well. And then you can go on to name another 20 to 30 easy applications of IoT, and at the end of the day, 90% of all of these are being implemented in today's world. So whenever you look around you, you will see an usage of IoT somewhere. So with the application of smart homes, so if there are smart homes being used everywhere, think about the end goal, think about the bigger picture. So basically this generates and creates smart cities around the world. With respect to smart cities, basically it's a combination of smart homes and multiple other features like keeping a database, basically keeping a database of, for example, all the people who use electric cars, and ensuring that you can create one single network where everyone can have access to their smart goodies and their smart products, which is powered by the world of Internet of Things.
In this first component of a revolution is like in mobile as a term, more IP devices than people nowadays. So this we are seeing nowadays. So each person used to keep two devices nowadays. So more than 1 billion smartphones at the end of 2013, it is the survey. At first we were looking into updated data, but 1 billion smartphones at the end of 2013, and the mobile affects the daily lives. So this is the major part. If I collect the data, if I collect the industry 4.0 data, and more of the data has to be given in the mobile based on applications, that's the reason the industries are targeting the first component of revolution is like in mobile devices. Going to the second part. So the second is the cloud infrastructure. So by keeping in mind the cloud infrastructure. So in this one, it is like once the data is collected, how this data has to be secure, how the authentication has to be done in cloud, and how the analysis has to be done in cloud, and what kind of an, after the analysis, what kind of an geo representation has to be done from the cloud. So all this process will be done in a cloud. So in this process, it is like, let me move to the next slide. So in this process, 67% of adult internet users in the US use personal cloud services. So in my mobile phone, first component is my mobile device. In my mobile phone, how much of an data I can store? It may be nowadays the devices are coming with 32 GB, 64 GB. It's not enough in my lifetime. So Google is providing a cloud with my Gmail, and Dropbox is providing me cloud. So in the same way, different cloud storages are there. So this cloud storage will access my data, will allow the users to store the data in my cloud, because I never like to store my devices the data in my specific device, in my physical device. So we concentrate more on to store the data in a cloud, and because of seamless access of the data from the different devices. So die cloud will replace the PC, of course. So no, we don't want an PC actually. And there is an NSA affair, means global surveillance disclosure. So NSA affair, just to, it is like an national security agency. NSA is an US based national security agency. So affair regarding the security of an cloud part and the authentication part, and also once the data is collected, how the analysis with whom the data has to be shared and it not to be shared. So because if I access in my Google or else in my Gmail, what all the data is there, if I give a permission to access to share my details, so how secure it will be. So all the information, all the part will be concentrated by an industry secondary revolution, as a part of a secondary revolution. So the next revolution is like in collaboration. Yes, in part of a collaboration, we have a lot of challenges. So the third component of a revolution of an industrial Internet of Things, that is an Industry 4.0, is an collaboration part. The main thing is like an challenges will come into picture, and the security will come into picture, and how the revolution will arrive. So that the part will come into a picture. So the main challenges is like an shift from centralized to a decentralized factory control system. So from the centralized to a decentralized, if it is centralized, the lot of data has to be keep on pushing to the same part. Instead of the decentralized, the infrastructure and the architecture has to be utilized. So most of the industry in the industry 4.0 the revolution, we are moving from centralized to a decentralized controlling system, and the mainly the security will be given. So it is not controlled by all smartphones. So robot should only be able to read certain RFIDs, not all of them. Means the specific part where only we can concentrate, only we can provide the access to the specific persons, specific devices, and specific users. How will the revolution arrive? So no Big Bang. There is no revolution in the way of a Big Bang will be coming to picture in the industry of 4.0. The fourth one is an real-time analysis. The real-time analysis is an major part. So in case of a real-time analysis, the fourth is like a big data. So in real-time analysis, the data is produced everywhere and coming to an in depth. According to IBM, so 2.523 exabytes per day will be produced. 1 exabyte means you can see how many of a bytes information will be collected, and 90% of data produced in the last 2 years. So everyday examples in industry 4.0, if I come into a picture for an examples of an everyday 4.0 in 4.0, it will be consisting in parking system, it will be a museum visit, it may be an online purchase or a comparison of prices, everything with related to an industry and a revenue process where we can collect. So it is like in general public based areas. So everyday examples will kindly consist like on different applications. So even in case of an parking museum or as whatever the applications we will develop, so the architecture and design will be very much important. Industry 4.0 is a name which is not only concentrated to an not only specific to an industries or a factories. It is mainly also communicate, and it is mainly concentrated on also the commercial products items like communicate with each other like fridge, notebook, or suppliers, TV, or a different embedded devices which will be utilized for an com- commercial process. That is called as an ubiquitous computing. So I'm coming to the management challenges. So global challenge and diversity. So we have a lot of challenges coming into picture. So global challenge and diversity in this part, networking of markets and companies, diversity management. This is the major challenge where most of the industries are facing. So networking of markets means what are the multiple different marketing areas, different sectors are there. So each of them will be the view or as the product selling way will be different. The diversity will be different. In the part of an demographic development and skill storage, so demographics is like an young and old. It has to be differentiated. Lack of young talent in skilled professionals, and also dynamic and complexity. So flow of information, sharing the information, advertising process will be the lack of the flow of information. Number of it may be due to number of employees or activities or structure and process. Strategic reposition and continuous improvement. This is due to the structural change in business model. New subsidiaries or companies mergers, or as there may be a different collaboration, and activities and structure of the process may be changed. So technological change and half-life of knowledge. This is like up to darkness of knowledge. Means we don't have a complete end-to-end idea and the architecture design, and innovations are improved general conditions. What are the upcoming standards? So what are the upcoming architecture designs? So as to be updated for an utilization, it may be in cloud or it may be in embedded devices part. So in this, in order to widely adopt new technology and product solutions, go through several steps. First is in standardization. So in case of a standardization, so all the security and different architecture design standards has to be utilized. So once for that standardization, conformance and interoperability is required. Once after the implementation, the main part is maximize and minimize means the optimization. So is it really required or not? The optimization process will be carried out. Once after the optimization passes, the product will be launched to a market. So these are the main four steps. So as will be gone through for an customization of a product and to release the product in a market. So here, once the customization depends upon the standards because we have to support an interoperability. Current process have major disadvantages. For example, extremely labor intensive, time and travel expense if because of an implementation where in Internet of Things will support when remote monitoring. If it is not and remote monitoring is not accessible, time to travel expense often too high for small and medium scale of an entrepreneurs, and time to market is unnecessary will stretch industries. This will make scary for an industry, small and medium scale entrepreneurs. So coming to the standards, so there is a need and urgency of Internet of Things standards. So Internet of Things standards, so specifically IoT is mainly concentrating into various things. So various things like an sensors and actuators with the use of an sensors actuators, and also in terms of power processing capabilities and bandwidth, existing set the protocol designs, and Gartner has forecast the total number of connected devices by 20.4 by 2020. So these are the different standards. I'm just moving to the next one. What are the challenges about for an Internet of Things standardization? Customers would be bound to one vendor for the entire end-to-end solution. So, for example, I want an interoperability in between multiple devices, means different products. One is from an Philips and another from an Google Assistant. So at that time, how the vendors will support each other, and the operational quality may not be uniform. So systems might not work as an expected because of the challenges specifically into the cloud or as an specific to the security. Interoperability issues incompatible with the other solutions. As I mentioned, it is maybe in the other vendors. Scalability is a challenge. Technology reuse and modularity. ease of innovation, development of entire end-to-end solution, lesser competitive monopolization of market, and I will be very much higher. The IoT standards environment is designed like this. So first one is like a communication part. So communication part is like an transmitting the data. So standards creation reflects business opportunity, and also it reflects the race of an about IoT monetization, creating the potential to the market transformation. So in the case of an communication, how the designing will be done with respect to the business opportunities will be utilized. Coming to the government sector, the formal standards in all five sectors are creating end-to-end Internet of Things architecture. In industrial, Internet of industrial operation, so standards will even become very difficult and not impossible. So at that time, the standards are required to make it standardized. And the end customer is probably not a person, but is an entity, thing, or a system. Because in case of an IoT, where things to things communication will be there. So, so these are all the different sectors kept in mind to standardize an Internet of Things. I'm just skipping one slide because of the repeated information. I'm coming to the point. Yes, I'm coming to the point where actual Internet of Things will be designed and out. IPv6 for Internet of Things. So there's an architecture design and where the standardizing body, IETF. I'm going to talk more about an IETF, Internet Engineering Task Force, how the standardization will be done and the architecture will be designed. So in this part, IoT, is it dependent on IPv6 or IPv6 is dependent on IoT? Somehow confusion. So because completely Internet of Things is dependent on IPv6 and the growth of an Internet of Things is like this. First the IPv6 technology came in picture, and then when we in use of an IPv6 is called wireless sensor network, and after the wireless sensor network we called it as an 6LoWPAN, that is an IPv6 enabled low power personal area network. So later on by making use of a robotic we call it as an IPv6 based Internet of Things. So I'm just introducing an standardization body for an Internet of Things that the global standardization body will support for an the challenges with respect to the IoT protocols or IoT standards. So IETF is an Internet Engineering Task Force large and open international community body, and it will support for an designers, operators, vendors, and research concerned with the evolution of an internet architecture and smooth operation of the internet. The actual technical work of IETF is done in its each and every working group. It have a multiple working group for a specific area. The main goal is to make internet work better, and the actually the definition, the IETF will always go with an wording. We reject king, precedents, and voting. We believe in rough conscious and running code. So this is the quotation which will be utilized by the IETF. The focus of an IETF in context to Internet of Things, emergence of new connectivity protocols for an Internet of Things, that is like an in the standard of an IEEE 802.15.4 TISH, that is an time synchronization channel hopping. This TISH is the main thing which will be utilized nowadays, which coming up design for an industries, actually industrial Internet of Things part. Low PAN, low power personal area network as it is popularly called. And then these standards, so like an IEEE 802.15.4 standards, and will be utilized for an like commercial product manufacturing. And the TISH will come in picture where it's an industrial standardization. So the next one is like an narrowband based, narrowband PLC, narrowband cellular, and Bluetooth low energy. So these are all the some more areas concentrated by an IETF and optimized old connectivity. So the old connectivity we have like an DCT or as ULE and NFC, MSTP. So this MSTP and all called as an multiple spanning tree instances. In MSTP is an specific for an in virtual local area network. It will be utilized throughout and bridging the local area networks. And NFC nowadays we are also utilizing specifically for some of the industrial applications. And these are all the designs we have from very long, and ultra low energy concept are the designs we have from very long, and the optimization will be concentrated by the ITF. The main focus, reducing resource usage. So control over it, since network traffic cost is way too high and memory overhead, since per unit device cost is too low. We in Internet of Things we are making use of constant devices. The main concentration, the main area of concentration is to reduce the resource usage. So I'm just going to show you the number of an device, number of an memory. So for example, we have multiple technologies in Internet of Things: LoRa, long range communication; Sigfox, IEEE 802.15.4, 15.4G, that is in Sun; RPMA, Dash, weightless W, weightless NP, and narrowband IoT. These are the different technologies, and each technology is differentiated from based upon the range. LoRa, as I mentioned, the LoRa can communicate. The range will come in 2 to 5 kilometers in urban, and it will be lesser than 15 kilometers in suburban. In case of Sigfox, 10 kilometers in urban and 50 kilometers in rural area for a direct one-to-one device communication. The same way, 15.4K is be lesser than 10-20 kilometers and the lesser than 5 kilometers for an in a line of sight. So in 15.4G, it will be like 2 to 3 kilometers, RPMA and L-7. So these are the different technologies. The mainly I am going to concentrate into the maximum transmission unit, MAC, data packet. So here, while transmitting the data, the IETF will concentrate into specifically the data size, which is very less. It will be in a kilobytes. We are making use of constant devices, which the devices will be having a lesser memory size, that is like 32 kilobytes or 64 kilobytes. And even some of the microcontrollers like MS430, F1611 were very much widely utilized in IoT, and Atmel, STM32, and ARM microcontroller, and different microcontrollers. Each microcontroller will be having very less RAM size and flash size. We can see the data size which is available will be as much as lesser than 10 kilobytes in class 0, class 1, and class 2. So the name classes based upon the availability of memory. So the devices are classified into class 0, class 1, and class 2. So each device will be within constant memory. So how to support these devices in an Internet of Things, and also the maximum transmission unit, the packet size. In the left hand side, you can see Sigfox only 12 bytes or else 8 bytes. 15.4K, it will be supporting in a 16 or 24 or 32 bytes. So these are the packet size supported by an uh, multiple standards of an Internet of Things. Supporting sleepy devices. The next one is like focus into a sleepy devices. Most of Internet of Things devices support for an battery operable, extremely high radio duty cycle (RDC). The next focus, security. Yes, of course, in Internet of Things, the IETF is concentrating for a security which such constraints. Each and every layer of an IoT will be using an security. If it is a network layer, layer 3, it will be making use of an IPsec. If it is an layer 2, like an A is an encryption process. If it is an transport layer, it is like an DTLS. Application layer, customized security. Lot of security will be provided in each and every layer of an IoT stack. This is the graph of an IETF or IRTF IoT working groups. IETF. So in IETF, we have a lot of working groups, and IRTF is a research task force. IRTF. These two are the standardized bodies. So supporting for an IoT standardization in this part, ART, there is an for an application and real-time area, INT is for an internet area, RTG routing area, security area. So these areas of an IoT is partitioned into four parts: application real-time area, internet, int, RTG, sec. In bottom of that, so we have different working groups. Art application. In case of an application, we have a core. Core is like an constrained application resource environment that is depend upon REST architecture, representation of state transfer. So this CBOR is an conscience binary object representation. These two will be utilized mainly for an application development. The next one is internet area. In internet area, the way of is mainly the way of concentration into a communication process. So 6 low IPv6 low power personal area network, 6 dish IPv6 time synchronization channel hopping process. So as I mentioned, 6 dish is the part mainly concentrated in amendment with an MAC layer, and it is concentrated for an industries. And low PAN, low power personal area network, and IWAVE. So there is an sorry IPWAVE. IPWAVE is one more technology for an wireless communication, and the last one is like an ITF LWIG, that is called a lightweight implementation guidance. So LWIG will give an communication any challenges in the perspective of an there's a specific working group for an communication in a local area network. So it has its own design. RTG. So RTG is an routing. So every Internet of Things, it is a mesh network. In case of a mesh network, multiple devices will be there. The routing has to be taken care. So in case of a routing, there are specific, the major nowadays utilized routing architecture is a role, routing over low power and lossy network. So role is the one of the routing protocol, and the next one is an DETNet. DETNet is an deterministic networking protocol. So next is security protocols. Security ACE and SUIT are the two security protocols. SUIT is specifically for an auto updating. So the firmware updates will be utilized. And IRTF is mainly the area in the very right hand side. It is concentrated only to the research groups. So things to things research group, and the determinist DINRG is the one more working group concentrated on the only into the specifically research area of routing process. So because right now the routing is only the DETNet and the role are the two routing protocols. So IRTF is mainly concentrating into routing as well as things to things, that is the end-to-end communication. I would like to tell some about an 6-low working group. So problems to deal with is an 602 IPv6 verbose and neighbor discovery protocol not optimized for an IoT, and multicast not good for IoT. Existing neighbor discovery protocol doesn't support CPU devices. So in this IPv6 itself, 128 bits of an size, and It is not at all suitable for an constrained devices which have a very less memory. During this time, so how to utilize the IPv6 technology into an Internet of Things come into picture? The 6LoWPAN. The 6LoWPAN major task is to compression. So header compression and the fragmentation of the packets. In the just concentrate on the right side of the diagram. So we can see multiple red nodes. So the small devices will be called as a node. So each node can communicate each other by making use of an protocol called what I just mentioned, role, and the edge router. So the router is the like a parent node. It can create an 6LoWPAN network, that is an IPv6 enabled network, and each node will be consisting its own IPv6 address. In this case, so the gateway is main responsible to assign the IP address and to communicate with an local area network and global area network. So during the communication process, the edge router is responsible in 6LoWPAN for header compression and fragmentation and reassembly process. So it will support an real-time access of data with an mesh technology. 6-ish is amendment with an MAC layer. There is one more challenge with the working group. The challenge is to an MAC layer where the industries are facing with, and they add their each and every industry add their own solution with respect to a proprietary standards. So when there is a proprietary standard, there is a possibility where the only end-to-end communication can happen, but interoperability will be very difficult. For that process, time-slotted channel hopping is introduced for an industries and provides quality of service, deterministic traffic pattern, and in industries to communicate from one device to another device, latency and the guarantee of the packet delivery is very important. For that reason, slot scheduling allowance will be included. So, radio duty cycle and quality of services provided and guaranteed packet delivery rate. So, the word guaranteed is mainly concentrated on industries because each and every packet is important. So, just I'm moving to the right diagram. So, the data screen divided into multiple frames. So, each frame is divided into time slots. So, based on specific time slot, means if 10 devices are there in IoT network, each device will be assigned with a specific time slot. For example, in 10 seconds, each second will be assigned to one device. So in the first second, only the device number 1 has to communicate. In the second, only second device has to communicate. In the third second, third device only has to communicate. Is the way where all the time slotting will be done, and it will be shared slots. The scheduling process will be seen in the bottom. We can see the shared slots and dedicated slots. So in shared slots, there is no scheduled cells, but in case of a dedicated slots, so that in the one channel number one, so channel number one channels and all means it is based upon the frequency. So in 15.4 it may be 2.4 gigahertz or it may be in sub gigahertz. So 868 or 915. So based on that one, the channel numbers will be there. In case of an 2.4 gigahertz, if we consider the channel number 1 to 26. So during the data transmission, the time is slotted for each and every channel. So we can see here in the first slot, if the device C is transmitting a packet to A, so none of the other device will transmit the packet. Whereas if there is a transmission, so there will be it will leads to a collision of the packet and there will be loss of the packet. So to reduce that one, to make guaranteed packet delivery ratio, so the time is slotted in between each and every devices. So this is the one more technology in updated technology in industrial Internet of Things specifically. So the main the standard is called as an IEEE 802.15.4e, that is an TISH in IoT. That the problem statement is defined in RFC request for comments 7554, and minimal IPv6 over 6 means routing, scheduling, security, all this will be implemented, and also some of the work is in progress. That is an interface layer, and also minimum scheduling function. First, dynamic scheduler means dynamically scheduling the time slots. If there are thousands nodes in my network, the time has to be scheduled in between 1,000 devices. So that kind of scheduling, dynamic scheduling process will be implemented. So in the right side, I would like to show the stack. So IoT stack for an 6 dish. I'll come from the bottom. IEEE 802.15.4 is the physical layer. So in top of that, 15.4e TISH, time synchronization channel hopping. So this is responsible for an in amendment with the NAC layer responsible for an channel hopping means synchronizing the time for an each and every on time slotted basis. So requirements for an IoT architecture. So I will first go through the requirements, mainly what from the IoT architecture is required as we're looking for an specifically into the business perspective. So where will be the challenges, where will be the consistency will bring up, scalability will bring up, and recoverability will bring up, and what are all the major areas we have to concentrate, and if it is an coming to the architecture and the each and every layer, what are all the specific if it is an application, if it is a data processing platforms, and also edge and the things coming to the part of an sensors, what kind of an sensors has to be concentrated. I will just go through right now. So requirements, supports for failure. So system should gracefully degrade into lower performing state. So one thing we must and should keep in mind. So when supporting for an IoT architecture, so there will be an constrained devices will be utilized, and the device memory will be very less, and we have to give as much as possible. The delivery ratio means the packet has to be, the network traffic has to be very less. So because, so as much as the data is captured, so as much as the data is collected means the transmission rate will increase. As the transmission rate will increase, my storage will increase. As much as my storage, data storage has increased, analysis process has to increase. So the system should gradually degrade into lower performing states, and means the and if a failed component recovers, it should be able to rejoin the cluster. So in this is IoT as is like a completely a mesh technology. So it is not like an one device communicating to an another. So as is not like an one machine is connected to an another machine. If there is any loss, if there is any device get failed, at that time auto recovery process has to be supported. So as I told, mesh technology, for example, in industries, in industrial Internet of Things implementation, if any of the device, it is like a chain, one device is connected to the another device, and that device will be connected to then two more devices. It is like a parent and child process in a tree structure. If any failure in that one device, automatically the device has to connect to another device, and it has to low power performance states. Recoverability is an event of a failure. No data should be lost. The retransmission will be implemented in between each and every node. If there is any failure, there will be an acknowledgement will be implemented. Consistency, failure to one task should not affect the result of the entire job. So it is not supposed to be the any device or as an actuation device implemented. It has to seamlessly operate and thus not to be dependent on any other one more device. For an example, if my cooling system or as if my temperature monitoring device, the cooling system is automatically, it has to switch on for every 1 hour once. it's not a completely dependent on the monitoring device. That's a temperature monitoring. Then, so if there is any failure in temperature monitoring, it is going to impact my cooling system. So that kind of automation we have to take care. So where at what time the temperature is monitored, and if it is not able to send it is not able to collect the data, my actuator has to give an intimation to the user, and the actuator has to perform its operation for every certain period of time to maintain it to reduce the temperature. Scalability, adding load leads to decline the performance, not failure. So as I told, so in the beginning, as much of data is increased, it will reduce the performance. So we must be and concentrated, we must be very unique to how much of data has to be collected and for what certain period of time. Increasing resources results in proportional increase in capacity and also scale up, but also scale down elasticity. Yes. In this case of scalability, we have to concentrate more into the data part, and we have to concentrate more into the proportional increase in the data. So if there is an random increase in data, how much of a data has to be partitioned? And in case of a cloud, if data is much, for example, AWS, and in case of an Microsoft Azure, IBM Watson. So just I'm considering three of the clouds. So AWS is my specific core, and if I have one more cloud, like an Microsoft Azure. So Microsoft Azure and AWS cloud are performing two different operations. I have to make them interact each other. In this case, the performance is going to reduce because of there's no interoperability and there is no proper scalability. So we must concentrate on one platform, and we must concentrate on the supportive and with a lesser data size. So at the eye level, this is a general IoT stack. So first layer will be considered as an application layer. So this next one, data processing and platform, edge, things are a device. So application, it is like an mobile devices or as an end device where we can see the analyzed data. So data processing is a platform where the data in a cloud, the data processing analysis will be done. Edge is the embedded device where it is responsible for communications. Things are devices are the part where the sensors and actuators will come into picture. This is IoT stack in depth. So application layer based on the color. So we have to concentrate. Application layer will maybe the websites and industry specific mobile apps, mobile any specific customized applications. So I will come up from the lower layer, sensors, hardware or firmware. So while choosing the sensors, so that is completely based on the custom application, on which application we are building, and specifically sensors has to be utilized, and the hardware. So what kind of sensors we are utilizing? Some of the sensors will be giving and data completely like an analog data. Some of the sensors will provide an digital data. Some of the sensors will provide an spy communication. Some of the sensors will provide an I2C based communication. So based on those sensors, we need to decide our hardware platform. So and the firmware for a security perspective, the hardware security. So EEPROM. So we will make use of on a hardware platform. We'll make use of a device like an EEPROM. So to maintain the security key to access my device. So and also for authentication of the user. So these are the part in a sensors. I will go in depth. And top of that one, the device gateway or as device management will be there. So device gateway or device management. So device gateway is or a device management is responsible to maintain the local area network. So the bottom layer, the sensors or hardware, the combination of the sensors, hardware and firmware will be called it as an, in IoT world, we'll call it as a node, or as we'll call it as an IoT in device, or it is also called it as a moat. So different wordings will be utilized: node, moat, or as an IoT in device. Once the data collected, so it can communicate with another device which is in a local area network, or the data can be sent to a gateway. This gateway is responsible to perform bridging in between local area network and the global area network. So once this gateway is switching, it may be to an Wi-Fi, in between Wi-Fi and Bluetooth, it may be an LAN to an Wi-Fi, it may be an Zigbee to Wi-Fi, it may be an Z-Wave to Wi-Fi, different protocols, it will be. So once after the data collected and transmitted from the gateway, it has to move to an cloud part. So in cloud part, so the API like an, once it's like an big data, once the data is collected, we will run our own algorithms for a machine learning, artificial intelligence, and to take care of an actuation process and the authentication, and API designs and API runtime management. This API design and runtime management is responsible to for an end users. What is API? Application specific interface. So these websites are as an industry specific, or as end users like an customers. Once when they are, it is not like a limited customer. So it is like a limited number of customers. So when there is a new customer will join, when there is a new customer will add to my product. So at that time, so we have to it is like a dynamically we have to increase the storage. Dynamically it has to increase up. It has to add the details of the user. So for all that process, we need an API call. API call is like an agent. It can communicate. It can allow access of the cloud from the customer applications. These are the four layers which main responsible, and the iPaaS is an APaaS is an like a middle layers for a security perspective. I will go through IoT stack devices are things. So the end devices are the things. Devices may be chipset or platform to choose, or becoming more and more vertically integrated with the software stacks. So these devices will come with a own address. Nowadays, it may be ARM microcontroller, it may be a Raspberry Pi, or it may be from Qualcomm chip. So Qualcomm Dakota, or as an Qualcomm Snapdragon, different chips. Or as it may be from Marvell, it may be from NVIDIA, Arduino board. So each and every chip, they are identifying by itself with own unique MAC address. So while choosing every device, we have to look into the processing speed. We have to look into the available memory, that is a RAM space, flash, RAM space and ROM space. So these microcontrollers, each and every microcontrollers are providing and customized firmware which is support for an Internet of Things stack. Each microcontroller, Intel Galileo board, it is like supporting with own customized stack SDK, software development kit. So once choosing the microcontroller, or once choosing the processor, we have to look into the number of available GPU pins, means general peripheral interfaces part, and also we have to choose. So which are all the onboard? Some of the devices are available with an onboard sensors, and with some of the devices are available with an onboard actuators. So big focus on prototyping, lot of tools to cater to the makers and thinkers. So we can see directly once I choose a board. So for example, if I choose some Intel board, or if I choose a Raspberry Pi. So Raspberry Pi, is it really just while building a custom application, or is it building a specific product? we have to look into the specific. Raspberry Pi is a processor, it will perform as a computer. It will be consisting LAN, it will be support for an Wi-Fi, and Raspberry Pi 3, which will support for Bluetooth also. So that product, which what is the application where we are using that will matters a lot. If we are interfacing only a single sensor, and if it is collecting only the data and it is transmitting the data in a mode, so lot of processing won't be done. Lot of local processing will not be done on the device. So if it is a Raspberry Pi of a device where it is be utilized in the places of gateways, so where that collect the data, analyze the data when there is no access to the global network, store the data for certain period of time, and perform the security process, perform analysis process. Yeah.
Okay. Now, as I understand, this particular board is having its own microprocessor,
Yes.
and it has some connectivity to the different sensors.
Yes.
Okay. Now, suppose if I have a older machinery,
Okay.
and say I want to connect a tachometer, or I want to connect a temperature sensor. So
Okay.
if I just take a plug and play board like this, say
Okay.
for example Intel Galileo or a Qualcomm board or something like that, and I put a temperature sensor on top of it,
Okay.
and so it might have one sensor or two sensors or whatever, three sensors or whatever it might be. I
Yes.
terminate all those sensors onto this particular board. Will that mean that that machine can become an IoT compatible machine?
Okay. I'm just looking at the question. So the controller.
You want me to repeat the question?
Yes, please once.
See, I have a machinery.
Okay.
Okay. Basically, I want to measure its rotating speed. Okay.
Okay.
I also want to measure what is the temperature within that particular machinery.
Yes.
I buy this board, say for example this Arduino board, or we say Galileo board. Okay.
Okay.
I buy a temperature sensor, and I buy a tachometer which measures the rotations per minute. Put those sensors on board this particular board. Okay.
Okay.
And will that make that machine IoT compatible? Because the moment we put this board, it has its own processing power, and will that machine become IoT compatible if I use this kind of integration?
Yeah. Okay. Okay. So once this is not like an IoT compatible Internet of Things, it won't become complete end-to-end supportive Internet of Things. It will support only end. So as one, for example, if you're compatible, like you will take a Arduino board when you connect a temperature sensor, the controller, the board, able to connect the data from the sensor, and it is able to perform the analog to digital conversion. And now that has to transmit the data to the internet. Until then, the user is not able to access the data. For that transmission, for sure, we need a gateway. So if it is, it may be in my Wi-Fi router will be the gateway, or else if it is in Zigbee, means Zigbee will be the gateway, Z-Wave gateway, different gateway. But for your question, for sure it will be it will be a supportive part of an IoT. It will be a compatible device for an Internet of Things.
I'm coming back to the same question. See, now the key challenge for us is not the gateway devices. See, gateway devices, you get a Dell switch or you get any other switches which you can connect to the devices. So for some of the equipment, what we have, older equipment which is not IoT compatible, and if you wanted to just make sure that the end devices, or the what we say, the bottom layer of the architecture is always to capture the raw data.
Yes.
Okay, so by buying these boards and then embedding with the sensors means that I will be able to convert that raw sensor data, or at least start sensing the information. Correct?
Yes, it will start sensing. You're absolutely right. So it will start to collect the information. So here, the only main thing is we have to concentrate is it the embedded device what we are choosing. So is it really good enough to collect the data or for my application? So the compatibility while looking, so the processing speed and also the storage memory size and also the custom application means what are the platform ID we are utilizing to build an application. So will it be suitable on that processor? So once,
Now I'll come back to the with a different question.
okay,
I have a 20-year-old machine blender. Uh, Say a mixer kind of a blender kind of a
yes,
industrial
yes,
scale. Okay.
okay,
Now that machine is never connected to internet or something. I want it to make it IoT compatible or sense what is the rotations per minute.
yes.
So if I go and say I arrive at a particular board and say and put a right amount of sensor and connect it to the board,
Yes.
so that machine will be made IoT compatible. Is that right?
Yes, that will be right. So until we collect the data, it doesn't matter what kind of a microcontroller. We are able to make use of a specific sensor, and if we are able to collect the data, so then it is compatible for an IoT. So for sure, once it is able to collect the data, for sure, once we're able to perform, means once it may be a number of rotations or it may be an temperature. So we can, it is like we can collect the data, means it is completely suitable to an Internet of Things, which means it is completely adaptable. The thing is, like, it is the main part is like sensing the data. Even instead of an microcontroller, it may be an Arduino, or it may be an Galileo, or it may be an Node MCU, whatever the platforms. In the main part, my old devices, if I'm to monitor the number of rotations or to monitor the temperature, once if I'm able to monitor the actual application, actual my surrounding, and if I'm able to give the information to the controller, that is good enough. Means the sensing part. Once we are able to perform the sensing part, we are easily, seamlessly, we can transmit the data. That is a part. That is a part of an Internet of Things. So big focus on
One more
prototype. Yeah, yeah, please.
One more thing, Adarsh. Suppose if uh, how these devices, how many sensors? Like, are there specific boards that which can connect three sensors, four sensors? Are there any specifications for the boards wherein we can onboard multiple sensors onto that, and then it becomes LAN compatible? Yeah,
Yes,
if
yes.
you can show that. Okay. Can you just go back? Yeah, at least we would like to see the diagram there.
Yeah, I just wanted to cover there. I'm just considering one year for your question. So I'm considering an Dragon board from the Snapdragon processor. So
Okay.
Snapdragon processor, it will be consisting multiple things, multiple. Like if the end user wants to collect the data from RS-232 socket, or else if it has to support from an Ethernet cable, or if it has to support from HDMI, means to if I'm controlling my TV and the TV has to be get displayed HDMI, and also if camera onboard monitoring, Internet of Things live streaming, if I need camera, and touch, if it is near the in front of a door, if I need an like a monitoring doorbell with a touch sensitive, including camera as well as touch display and the Ethernet part for an internet access, and to talk, so audio jack, and to store the information at local micro SD slot, JTAG, and also onboard sensors. When coming to the picture, for the specific question right now, what you asked me, multiple sensors like pressure sensor, temperature sensor, proximity, ambient, accelerometer, gyro. So these are the multiple sensors, and for communication purpose, we can have two things. One is like an WLAN, local area network wireless, and the Bluetooth. So this Snapdragon processor is the one which can support seamless for multiple applications. We can optimize. I can utilize this one like an video door phone. So where I can make use of an audio jack, keyboard, touch screen, and also my camera, and to access the internet, WLAN or Ethernet. In this process, the high-end processor, if it is my custom applications and completely high-end based, I will go with a Dragon board. If the smaller part of this Dragon board is like a Raspberry Pi. We can consider Raspberry Pi. In Raspberry Pi, we will be having an Ethernet port, and we will be having some of the GPU pins, and we will be having an processing and also Wi-Fi technology for a wireless communication. So in this case, we may don't have any onboard touch screen display. We don't have multiple sensors. So at that case, our BOM cost will also reduce, and also based on the processing and also the technology what we are using. If I am going with an Wi-Fi or a Bluetooth, and if I'm not going, or else if I'm making use of a Raspberry Pi 2, if I'm making use of only Ethernet port and some of the sensors, then Raspberry Pi is good. And also when we are performing some analysis, so because Raspberry Pi is an end processor, if I'm doing some analysis in my local on my embedded device, if it is good, if I want to reduce even some more price, then I can go with an even lower one, that is like Arduino board. Arduino, or as an some of the devices like a Node MCU, that is a ESP8266, which is a Wi-Fi compatibility, and we can go with some more Texas low price microcontrollers. So these microcontrollers, what will be the main differences? So the main difference is like supporting the number of interface, like an input and output interface, and those devices, it will be having one single wireless communication. It may be not an Ethernet port. It may be only the wireless communication for Bluetooth. So nowadays the chip is coming called SoC. Since I was just now I understand one thing as like more into business perspective is required. I will include some more slides for with respect to the business and to differentiate the embedded devices in my further slides. So for those, when based on my custom application, just if it is 2 or 3 sensors, I can integrate with my microcontroller and I can transmit it in a local device, Arduino kind of a device, a very good enough. That is an ESP8266 Node MCU. So if I want to do some local processing, then I will come with an Raspberry Pi. So if I want multiple sensors, and if I want high-end process like a display or some video streaming in a, and also CCTV camera, so high-end processing is required. At that time, I will go with an like a Qualcomm, Marvell kind of an high-end processor chips. I hope you got an answers of even the actuators also. So we can integrate this like the actuators like the display and the keypad. These are like an actuation, so we can like an siren, buzzer, and it may be an some of the visual effect, the light indication. These are the actuators can be integrated. So as the number of price increases, so of the board or a microcontroller, the number of interfacing options and also the number of the mainly specifically the local storage RAM and ROM space will be increased.
Others, what about those sensors? See, we talked about the board, and what about those sensors? Are there any specifications, or are there any sensors available which readily talk to this kind of this boards?
Yes, we have. So that's about my next presentation. So this is a board. Even for board, I will give in tomorrow presentation more because I wanted to understand. This is our first discussion. Wanted to understand the expectation. This gave me the real actual expectation what I'm looking for. So I will give in detail more about the board even for tomorrow presentation. So sensors, yes, as you have asked, there are so many microcontroller boards which are coming up with onboard sensors. So onboard sensors means like, and some of the boards are coming with onboard temperature and as well as humidity. Like, and for example, single sensor can monitor multiple parameters. There is a sensor called as DHT11, DHT22. These sensors can monitor multiple parameters. So some boards are coming with an accelerometer. Some microcontroller boards will come with an onboard compass. So these are the boards which are readily available. Means just like a plug and play, just connect give a power cable and start collecting the data. No need to interface because the onboard sensors will be there. So temperature, radiation, oxygen content, and also noise, moisture, humidity, GPS, carbon dioxide, ultraviolet rays. So In case of an with respect to the health, in case of an respect to the activities, applications, so the sensors will come up. So as I mentioned, one is like an onboarding sensors and another an external sensors. So external sensors are some of the sensors, system SoC chips are coming in market. Those devices where we need an interface in between the microcontroller and also the sensor part. And some are the sensors are more very much intelligent as like we can pre-program them in a firmware. So when it reaches the threshold value, at that time only give an notification means to the controller. So the sensor will keep on monitoring, it will give the information, it will give the data only when it reaches to the threshold value. So sensors, most of the sensors input and voltage like an access voltage like an 3.3 volts, and it will be like and some sensors will give an analog data, some sensors will give an digital data. So analog and digital, these sensors will need only single GPIO pin interface on the microcontroller board. Some of the sensors are there like an accelerometer. They need like an for a spy communication they need 4 lines, 4 GPIO interface, and some need I2C, so they need 2 lines of a communication. So that depends completely onto the sensors. So, and in market, we will get multiple sensors, including the LM35 kind of a temperature sensor. So LM35 temperature sensor, it is like an can monitor the temperature from minus 35 degrees Celsius to 110 degrees Celsius. Thing. Yeah. So this is a very minute. It depends upon the size also. The size also matters when we go to a product. As the size decreases and MEMS technology is implemented, so the price of the device will keep on increases. So this is the part of a sensors where the microcontroller and the sensors even more required information. I will provide that information. So and coming to the device or gateway or device management process. So device gateway or management means the main work of a gateway is like similar to my router in my home. So whatever the network, whatever the device. So when I create an IoT network, the gateway is required. When we go to the market, so in business perspective, if I am going to sell a product like a single bulb, and if I for single bulb is on Zigbee, and if I'm asking the user to buy one more Zigbee gateway, so the user will think to buy single bulb, why I need to buy a gateway like a Zigbee gateway? Because Wi-Fi router is there. So the user preference will be on Zigbee Wi-Fi based bulb. So if it completely based on application, if it is like for number of devices are very much less, and if it is not, if it is like continuous power consumption one, like if it is completely able to access the power from the main grid, then the device which will go with an Wi-Fi will be very suitable. If the devices are more battery operatable, like my door lock or else my thermostat, these kind of devices has to go with an battery operatable devices. This will be with an technology like a Zigbee, Z-Wave, 6LoWPAN. These devices will be like come for a lifespan of 3 years, 4 years, and this will be device will need a gateway. The gateway is the main work is to collect, aggregate the device data and manage the devices. What the management of the device? If there is any failure of an routing, means in a mesh technology, mesh routing process, it will perform, it will handle, means routing table will be maintained, and it will handle creation, auto creation of a network. The gateway is responsible for and storing the local data. Gateway is responsible for collecting all the information stored in a main processor, as like a Wi-Fi router. So typically the combination of an localized gateway and a cloud-based gateway at the edge will be looks like this. So the cloud-based gateway is like some of the gateway will be like in cloud, and we can see here at the very top the small network. So this is the one small network. The small network is like similar to my home network. Single device are connected to a single gateway, and that gateway will transmitting the data to my cloud. So some of the end devices will transmitting the data directly to the cloud. So my cloud will be the gateway which is connecting the multiple networks. So, as I mentioned, the main capabilities of a gateway is to connectivity, routing, aggregation, software management, and events. The event may come up anytime the data can be come to any device from the any device, controlling the events, transformation, registry, actuating the devices. Means the user may send some from the outside global network to the local network or local network to the global network. And security is the main part given by the gateways. The provisioning. So these are the main capabilities has to be handled from the gateway. Device gateways are going to be very challenging. So in case of an too many disparate ecosystems are there in nowadays, because each and every device manufacturers have their own ecosystem. One is like a Bluetooth, Zigbee gateway, Wi-Fi gateway. CoAP is one of the emerging protocol. Most of the industries are using constant application protocol for an products. MQTT, message queue telemetry transfer, Z-Wave, proprietary standard is in Z-Wave. And AMQP, DDS are the different technologies. So each and every technology need a gateway. For example, my Fitband for Bluetooth, my mobile phone is a gateway. For my Zigbee, separate gateway for Wi-Fi, my router is a gateway. So each and every device has to come up with a gateway, and there's specific challenges in there. So to overcome this challenge, the interoperability between the devices and machines has to be come up into picture. That is to be come up from the gateways where it can support multiple network stacks. Up for all, yeah. Up for all. So one thing in product perspective, up for all. So nowadays the user used to prefer a single device which can support with the user which can buy one device, and the same device as to support as a router, and the same device as to operate as a Zigbee gateway, the same device as to operate as a Z-Wave gateway, the same device as to operate as like a Bluetooth. The good example is an Amazon Alexa. So Amazon Alexa Echo Plus will support for an Zigbee, will support for an Wi-Fi, will support for an Bluetooth. So like in multiple nowadays, like in D-Link, TP-Link, these kind of routers are coming up with and supporting Bluetooth and as well as Zigbee, Z-Wave platforms. Data management and intelligence. So this is comes in a part of a cloud perspective. Capabilities required in data management in cloud. So as a cloud is like main capabilities like a data HTTP connectivity, real-time data processing, batch processing, and routing of the data, or some big data analysis, and pattern retraining process. Retraining means which will come in an artificial intelligence and machine training process, driving focus identifications, predictive analysis of the data will be performed. And for all the data to access, REST is the architecture, representational state transfer, API calls will be utilized for an as because nowadays if any solutions coming up, REST architecture, API calls will be ready. If Amazon AWS is giving means, you can see that they are giving a ready SDK with an API call. Just call this API call, you will get the list of all your database you can access. So in the same way, just store the information of and segregate in a cloud, and this is the API call directly. It's an easy plug and play kind, even the cloud nowadays. This is an API design and build runtime management. So API lifecycle tooling platform will support own mainly for an applications. So I will try the design time capabilities. Since this is more into some more technical part will come up here, I'm just not concentrating more, digging into more into this. So API specifications, mocking, reusable API patterns, deployment automation. So here, as I mentioned, reusable API, this is more suitable because as number of customers have increased, as number of for example, my cloud has to be generic. It has to be only specific. So where I can onboard multiple custom applications in an IoT, it has to be easy and there is no requirement of reinvestment on the same thing. So sensor devices are becoming widely available. So it has to be an customer. It has to be an like a unique and constrained device. So we can see here one green color board. So this is called as an telos B or crossbow mode. So for some of the R&D that it will be utilized. It is a consisting microcontroller MS430 microcontroller F1611. It have two onboard sensors, temperature and humidity sensor, and it is a battery operatable. So two Duracells, and you can see most of the devices like an one coin cell based monitoring their temperature thermostats are available, and also key chain programmable devices are available. These are all the small gadgets which are already available in market, and these devices require a gateway. Some of the devices requiring consisting an mobile device as a gateway, or some of the devices are accessing Wi-Fi as a gateway, and some of the which are devices which are working on GPS based technology for monitoring. Those devices are directly accessible from our mobile phone and the applications.
We are concentrating mainly into the business perspective of the some of the applications implementation and the embedded device selection and the sensors part,
As well as some of how to make use of the protocol selections.
so sensor device means there are like multiple sensor devices are there.
Today we can discuss in depth of an application development, how can be done for an industrial Internet of Things. So the most important points that we need to summarize is like some of the points. Just I will start from by summarizing some of the points that specifically mainly required for an Internet of Things. So that is like an some points like an applications, flexibility, architecture, speed, verticals, context, structure, and growth, and also the data ownership. So these points are very much important to be the part of an Internet of Things. So just I will go through one by one. There is no specific slide for that. I want to just explain that one later, and I will go to choosing the sensor part. Applications development. Applications development is a very important part, one of the important part in the Internet of Things, where M2M applications, machine-to-machine applications, are about connecting the devices and their associated applications instance. Like for example, a smart meter and a smart metering application. In the same way, IoT applications are potentially far more complex. They are characterized by complex event processing. And also, these applications has to be data analysis and offer high-level services. It is not like a simple applications. So that's the reason applications is one of the most important point in Internet of Things. The next coming point is like a flexibility. What we mean of flexibility means, while coming to the M2M application, it is typically functionally specified. Means it is mainly dedicated and quite inflexible. I mean, IoT application need to be more flexible in terms of its potential to evolve over time. It is not to be a more rigid. It's not supposed to be more constrained. It has to be more flexible in the point of a potential to evolve over certain period of time. The next point is like an architecture. The architecture of an Internet of Things is the most important one. Many machine-to-machine applications are deployed with a relative rigid and unchanging solution architecture. Because the technology will keep on changing. We have to keep on updating. Means we have to keep on updating the embedded system. Maybe we need to keep on updating the sensor part. We may need to keep on updating our cloud. So at this condition, the architecture will play a major role. So the deployed relatively rigid or unchanging solution architecture is not suitable. While in case of an IoT applications are characterized by their need for distributed and federated process, storage, querying process, are some of them. When this IoT applications is deployed, software engineers have a pretty good idea of what processing will need to take place over the entire lifetime of the solution. So conversely, we need, because of the range of IoT application is ever expanding, and individual applications are often
diverse from the some data feeds, different aspects of different IoT applications that may leverage some certain period of time. The same data feeds might most effectively be located in different places. So the data architecture has to be most suitable. The architecture has to be not supposed to be a rigid and unchanging solution. The next one coming to the speed. So when coming to the point of a speed, I mean potentially minimizing the transmission and processing delays. So the delay or else the latency will be the major role while transmitting any data. The speed matters a lot. So while processing the transmission and processing delays to be better support for data analysis. Speed can be designed into solutions as needed, means and applications are capable of supporting the necessary speed requirements from day one of the implementation. In an IoT environment, however, the need for delivery and processing of different data feeds may evolve and change over time based upon the requirements. The next most important point I would pick up again verticals. So in IoT, the mean of a vertical is like related to a difference between the M2M and IoT. M2M means the application should be considered in the context of industry verticals and functional natures, where IoT, in the case of IoT applications, the potential to transcend these limitations to become cross-industrial, cross-functional applications. So these are verticals we need to concentrate in case of an M2M and in the Internet of Things applications. The more context part. The next one is the context part. It is mainly to support the flexibility of environment. It is necessary for some IoT applications to be semantically rich for associated and contexts. I mean, this is not the case for like an machine-to-machine applications, where data generated by an application only needs to be meaningful in the context, the specific application within the boundaries of a known system environment. It is not supposed to be an unknown system environment. That is the way of being specific to the context. The next point I will like a structure. The one more important point is a structure is an important point for an Internet of Things. In this structure leads to a wider point about the structure of data. In case of an machine-to-machine technology, data is highly structured, and it is also well documented. In case of an IoT environment, developer may want to include, for example, CCTV feeds into an application, or as a cross-ordered information or information derived from the, for example, a Twitter sphere. These information sources are the best semi-structured and also the worst completely unstructured. So the structuring of the data is very important in case of an Internet of Things. And also one more thing is like a data ownership at last. So data ownership in case of an Internet of Things, it is like worth touching the topic of data ownership. So like while data ownership in the case machine to machine, connected solutions can often be unclear. Maybe the concept of data ownership is like in case of an Internet of Things environment is far more complex, where it will be handled in cloud. In case of machine to machine, the privacy of data can be considered within the known landscape of application, users, and regularity requirements. But in case of an IoT application, however, data could potentially be used for mainly unforeseen applications and unforeseen locations, unforeseen beneficiaries. So these are some of the areas where the data ownership will come up. The major and this data ownership is one of the major aspect of the Internet of Things. The large companies will have to deal with it effectively if they do not want to lose their any customers trust, because at last everything will come with an customer trust. So each and every data ownership is much more important. And I think one more thing is like I want to like about the growth. The growth, coming to the point of an growth, in case of in perspective of an Internet of Things, growth related to difference in the speed of growth that can be expected in between the machine to machine and Internet of Things environment. In case of machine to machine application, growth is like far more predictable. Typically is designed for a specific market. I mean, the machine to machine is specifically designed for a specific market or set of assets and can be deployed in addressable market in the relatively predictable way. And also the data generated by machine to machine solutions would typically grow linearly with the devices, number of devices increase or number of device count. The growth is in data volume, or as the growth in transaction volumes, or as the growth in applications in an IoT environment is driven by network effects. The network effects means it is indifferent between the diverse range of data sources. So these are all some of the major points like for an Internet of Things mainly need to concentrate. As I mentioned, application flexibility, architecture, speed, and structure, growth, data ownership, verticals, context, some of them. So moving forward, I'm starting today with choosing the sensor. How can we choose a sensor? So I'm concentrating one sensor by taking an example. How can we choose a temperature sensor for an Internet of Things? So sensors means it completely depends upon the application. So what kind of sensors we have to choose, what kind of applications we are developing, based on that we have to choose. And also sensors coming to the part, the accuracy. So accuracy of the data is required means the BOM cost will increase of our project because of we have to go with a more accurate sensors. So sensor selection and integration in this point. So the mainly we have to concentrate while choosing any sensor. It is not only for a specific temperature sensor. I am choosing only temperature sensor for an example purpose. So if by you choosing any sensors, we have to concentrate mainly on the cost. How much it will cost? Because the cost at last it will come up with the final product, and it is going to be the range of our revenue, how much we are going to be the profit. We're looking into the profit. The cost we have to look into for number of how many number of device the mass production, or as we are going with a certain number of productions, how much will be the cost in the mass production, how much will be the cost. So these are the things we have to concentrate, and this cost scalable. If I use the component, and this is important to consider so that the solution remains truly cost effective. So cost has to be the major first part, because it has to be within the suitable of our budget of our project, and how much is our final product I'm going to sell it out in market. Supplier, where can I get it? This will also matters a lot, because so the same product, the same sensor can be sold by multiple vendors. So for example, like temperature sensor from Texas, I can buy it from multiple online websites. It may be an Mouser, or it may be another something. So everyone will sell. From whom I have to buy the sensor? So the most trustworthy is the seller. So we have to concentrate. Is it trustworthy? Can I get the replacement? Can I get the device in a specific time? So, and also make sure the supplier has reviews for other buyers to indicate some on-time shipments and quality. So these 2 points are very much important, because the complete project, once it is done, so we will have a certain our time slots. So can we able to go with an on-time shipment and the quality from the supplier? So choosing a supplier will also play a major role. Accuracy and precision. How reliable are the measurements? So this all comes under the calibration process. So the calibration of a sensor. So how reliable are the measurements? How accurate and precise do you need to more your measurements to be? So monitoring biological stock in an industrial farm will require more accurate temperature sensors than monitoring the conditions in the living room. Of course, the more accuracy has to be there, and these sensors are has to be well calibrated, and we have to make sure that the sensors are well calibrated because we won't keep and compare with any reference temperature device. So accuracy and precision will be the one of the major point we have to concentrate while choosing any of the sensor device. Accessibility. So while starting my project, so in the case of an accessibility, can I get from my planned project? And what is the scale of the project? Certain components can only be bought or ordered only when the demanded size of the millions. It's important to know the minimum batch size is compatible with your industrial needs, of course. So the point is mean to tell that how many devices, how many is it is like a mass production the company is going on. So this tells is the industry is concentrating for a few number of pieces. Of course, so many companies, so many. For example, I am producing some of the temperature monitoring, but I need one temperature sensor specifically, maybe from Atmel. So Atmel may be not able to provide so certain only for 10 pieces or 20 pieces. It has to be maybe in a mass production, mass number of devices. So before the plan, before selection of the device, we must have an idea and the proper design for the flow of the project. Measurement range. This matters a lot because in market we will get so many temperature sensors. So am I measuring the temperature or of a device is it less than 0 degrees Celsius, maybe minus 10 degree I want to, or else it may be more than 100 degrees Celsius. So in market we will get multiple things like in sensors, but what is the measurement range? Will it suitable for my application? What range will it work for? It would be full RD to get temperature sensor that works above 40 degrees Celsius to monitor freezers. We have to make sure those things and will it applicable and can I make use of it in my application. So the last one is power consumption. So power consumption is also plays major role in case of an sensor selection. Some sensors will consume power less than like 3.3 volts. Some sensors may need 5 volts. Some sensors may need 12 volts. This is the complexity where if the sensor, I'm choosing a sensor pretty good and it is able to suitable for my application and with respect to the range, but if it is consuming 12 volts and I'm going to deploy it in a remote place, so from where I can provide it for 12 volts? By providing it 12 volts, can I keep the device for a number of years, 3 to 4 years? This all the by planning. This is the called a planning before the while designing of a project. So while choosing of a sensor, the power consumption is also a major part. So will it work with power source I have? Because most of the sensor devices, like you can see in market, so many IoT devices which are coming will operable in a battery cell, the coin cell battery, the smaller one. So if that is the case, we have to make sure that and the power the IoT sensor consumes is compatible with the system. It would be disaster if the circuit has too much current and blows out the sensors also. That is also another scenario. So in this case, these are all the major points we have to consider while choosing any of the sensor. It may be temperature sensor, it may be pressure sensor, it may be humidity, oxygen, dissolved oxygen, anything. Like one thing I want to mention here, like while selecting the sensors, the sensor requirement is divided into specific, is classified as some certain specific things. Like one is like an customer sector and industrial sector. So this customer sector means in sensors, while choosing the sensors also. So we have to concentrate on the points in the business perspective. If it is a customer sector, consumer sector, so we which is our focus here, cost targets, which is very high, tight targets, and also the number of units is medium to high, and also product life cycle are short, and which means it must be possible to update the software, and also sensor nodes must be integrated into the home as much as possible, and also so they must be often be very small, the size of the sensor nodes. Actually, usually what will happen is it must be the user will expect them to be easy to install. If it any small sensors, if it has to be very pretty small size, and it has to be like a plug and play. So I have some examples here with respect to the sensors. So I have one sensor here, like, and to give some of the examples, that is from the Texas Instrument. From the same manufacturer, we will get multiple sensors. So the main difference will be the voltage, means the power consumption, and one more difference may be the range and the accuracy. Accuracy, based on the accuracy, the price will also differ. Some applications may need more accurate data. Some applications like a smart home, so those kind of an applications may not need more accurate data. So this kind of temperature measure instruments, like in this LMT84LP sensor, the sensor that we choose or cloud connected sensor. So it will be having a 3 pins, so it is easy to integrate. So it will provide an analog output. It's got great precision and very competitive price with the industrial grade quantities. You can see it is like an almost $0.91, and supplier is Mouser Electronics. So I told the trustworthy supplier we have to concentrate while choosing any sensors, and accessibility available in various industrial quantities, but also smaller batches. Accessibility, the number of pieces, how much it is required for us. Accuracy, this matters a point based upon our application. Zero point 0.4 degrees Celsius accurate, plus or minus. So the accuracy of the sensors, if it is like accuracy like plus or minus 3 degrees Celsius, 4 degrees Celsius, that is be very awkward. So if my room temperature is 20 degrees Celsius, if it is showing like 22, 23, that is very different. Yeah, that goes based on the sensor's accuracy. So this 0.4 degrees Celsius. Measurement range is, we can see here, minus 50 degrees Celsius to plus 150 degrees Celsius. So in industrial applications, we have to concentrate on this measurement range. And the next one is like voltage, 1.5 to 5.5. This is pretty good. So it is like a variable. Moving to the next one, the same.
Others,
Yeah.
one question. Can you go back to the slide?
Yeah.
What do you mean by cloud connected sensors?
Okay, so cloud connected sensors. So we choose for cloud connected sensors means here in this point, the sensors that we choose for cloud connected sensor, the sensors will be having a firmware and also having like an completely the stack ready, like an, as I mentioned, plug and play. This is a sample. It is the picture which is shown, the sensor picture which is shown here is not in cloud connected. So firmware, the Texas Instrument, we have there some of the sensors, like in cloud connected sensors, where the firmware is completely ready. Just what we have to do is we have to just customize some application part, and if you allow, directly it will communicate with the Texas server. Or else I can change the IP address and I can make it to communicate with my server. So the complete IT stack. So SOC can be based off of sensors. So some of the SOC chip will be consisting with a controller and the combination of controller and the sensors. So this can communicate directly to our server and transmit the data.
Others, then do you require a board in that case?
Okay.
Yesterday we talked about those boards. Okay,
Yes.
some boards were there. So in this case, if you talk about a cloud connected sensor, do you mean that we require a board, or can it be just connected to a gateway and from there the sensor can push the data to my IoT applications?
Yes. So At that in that cases, it's very good question. So we don't need to go with an again with a board. So if I am just sending a raw data, I don't want to go with an board. I can push the data to my gateway to the cloud. So
Okay.
this is the stack will be ready. The stack ready because here in my previous slide I mentioned. So even the manufacturer will prefer for a shorter duration to keep the devices in market as soon as possible. They don't want to go from the scratch. Texas Instrument or any other manufacturers have an idea. So they want the industries to move fast to release the product with a shorter duration. So they don't want to take the sensors, provide the analog to digital conversion, perform, and the software part. They are providing the software part. If we go and if it's search Texas Instrument IoT, Texas Instrument will support for Zigbee stack. Texas Instrument will support for 6LoWPAN stack. Texas Instrument will support for Bluetooth stack. So these are the stack which are all already ready available in their devices. So we can make use of them directly and to connect to our cloud. So some like student projects. So for example, some like kits, student kits will available. Those kits. So just out of box, the user can open a mobile app and can control. So means the Bluetooth. For example, Bluetooth stack will be ready, will be available, and the sensors will be there on it. So out of box, the kit just the user can open it and he can connect his mobile phone to it and he can control. And the same way for Wi-Fi also. So some of the they can connect, just place a out of box device and connect to your provide your Wi-Fi credentials and connect to the Wi-Fi and start accessing the your temperature of your room. So this is all the Texas Instrument or any of the companies are providing ready set of devices into market. So this will lead the manufacturers to go to a market and boost up the time to go to the market in shorter period of time. This is like Texas Instrument, one more product like LM35DZ, although used commonly amongst do-it-yourself community. It is not something that would be able to fulfill our needs for sensors suitable in industrial usage due to its precision range and cost per unit. So the cost is like we can see here, the last one is like $0.91. It is like the pretty double 1.86. The supplier is DigiKey, and even we can see the range of the temperature is 0 degrees Celsius to 100 degrees Celsius, and the accuracy is very much bad compared to the previous one, plus or minus 1.5 degrees Celsius. And power consumption is also very bad, 4 volts to 30 volts, where I can't run the sensor in by keeping based upon the battery operatable. So this is like an this can be usable for some lab experimental purpose, so or to build a proof of concept, or else to do some training sessions. So this kind of a do-it-yourself community, that's the reason it will be utilized. Moving to from one another brand, Sparkfun. So Sparkfun wired probe sensors, because all the time the sensors is not supposed to be an as we seen for the Texas one. Maybe sometimes I need like a wired probe for some certain distance. I need to run a wire. So at that case, this is like a price tag. It means it is like an was not suitable for our intended usage on industrial farms, but might be interesting for the working in more extreme environments. So the cost is pretty high, is like an almost to an $9.95, and the supplier is the Sparkfun, and accessibility available for various industrial quantities and also for the smaller batches. The accuracy is very good, like zero point 0.5 degrees Celsius, and the measurement range is also nice, like in my 55 degrees Celsius to 125 degrees Celsius. Power consumption 3 volts to an 5.5 volts. This is the variation, but even the same features based upon the manufacturer, so based on the vendor, so the price will change. I have one more. This is like an almost like an onboard, like as I mentioned, like and this is one more cloud connected sensor. So this is like Atmel's. The last one is the Sparkfun. This is from the Atmels. So with the price point much more hectic than our pickup from the cloud connected sensor. So we passed over this choice only because of the less precise nature of the instrument. Yes. So here we can, one major thing is it is not available for a small number of the set. It has to be at least minimum like 4,000 quantities are required. So 4,000 plus quantities only it will be served from the Atmel. So the supplier it is DigiKey. So the scaling cost price is like almost like in Texas price like in 0.53, and also the temperature range is very good like in 55 degrees Celsius to 125 degrees Celsius. Power consumption is very less. In the Sparkfun we have like 3 volts, but in this one 1.7 volts. So we have to concentrate one thing. If it is like more than my products are more than 4,000 and above, at that time it's good to go with this sensor. If I'm not able to go with 4,000, there's no guarantee. Then we have to fall back to the Sparkfun or Atmel. Now I will go with an one application that is like an vehicular application. So cars, and that is specifically to an Zoom car. So the Zoom car, I was just discussing with an the Vinayak Hegde, the CTO of Zoom car. So at that time, I got some ideas how the Zoom car is working on and how the Zoom car is implementing, because Zoom car just recently IoT based cycle, IoT based cycle, the car doesn't pedal. They have released in Bangalore. We can see in most of the places the pedal. The main question is they are investing a lot and they are charging only like 4 rupees, 5 rupees in Indian rupees per hour. Is it really, are they able to get profit on it? That's the big question. So keeping all those things in market, I am just concentrating on cars and cycles to give an idea. So introductory price of that one is 1 rupee for half an hour, the pedal. So can we get in profit in this? So what Internet of Things is, that is completely IoT based and it is controllable from the app. So first thing I will just look into the car part. So when we comes to the car, so data, the mainly we have to collect all the most means the device, the car has to be connected completely to the cloud. So we need to gather lot of information, lot of data at that time. So one may be a battery level, fuel level, gear information, vehicle or engine speed, braking behavior. So these things, this top 4 5 things will tell the user how is it like an is using very rash driving, or as how the vehicle is utilized. So this will give an idea so to predict how long the vehicle can come for an can be in good stage, and when the vehicle can come for an service, or when they need a service. So again, battery level, fuel levels, gear information for how long the certain time the gear will be changed on a vehicle, and also GPS coordinates. GPS coordinates, of course, for to keep on tracking on our vehicle where it is mainly required. Immobilization, keyless entry. Keyless entry, I felt very interesting part. So in the security perspective, so keyless entry, for example, if I have took the Zoom car for a rent, if I am able to from my mobile application, I can unlock my door. So if I am able to unlock, I can pass that application to my user, means credentials to the user, means one more user to one of my friend, and I can ask him to drive it. So at that time, so it is like an misleading. So I have took the car for a rent, but I am asking the one of my friend to take the car and to go. So to avoid these conditions, the keyless entry and keyless engine start. So they are maintaining two completely security perspective. So keyless entry. So the user, they don't need to provide any physical keys. The mobile application is responsible to unlock the door, and the same mobile application. So the will take care of and to make sure that the first installed app based on the MAC address. So the device is there in the area and to get start the engine to get start.
So two ways of an completely two different keyless communications will be performed. One is for an keyless door entry, and for one another is for an engine start. This is to avoid the misusing of our products which are already in market. Cycles. In cycle, actually, the locking system is completely IoT based. So where the user can go with an Paytm just from the scan and unlock it, or else in Zoomcar app, just scan and unlock from the Zoomcar app, some OTP they will get, just enter the OTP. So this kind of things, lock and unlock status is completely an IoT based, GPS coordinates and battery level. So in cycle, we may not observe that where is the battery level. So because where they have kept the battery, we may think that in cycle in the pedal. So in an automated vehicle, the back side the lock consisting in some manual battery, but it is like an rechargeable battery, solar based rechargeable battery is placed. Applications, what are all we want to in any vehicle or as in any IoT based applications, damage attestation like in detection, and driver score or as behavior, because for the next time while accepting the request, we must know how we keep on using the vehicle, and assessed usage or breakdown predictions. So these are the some of the applications we'll concentrate to monitor from the Internet of Things for mainly for the vehicles. So main challenges in building IoT system for vehicle is different standards, different versions. Like one is there, Bluetooth is there, one is like Wi-Fi or hotspot will be there, Zigbee will be there. So different standards, which one? Because it has to be unique to support all the customers. So some, it's not like I will use Zigbee or I will use Bluetooth, I will use like a Wi-Fi kind of an hotspot. So it has to be unique where it can support for all the customers, variety of platforms, like an onboard means to monitoring purpose. So onboard diagnostics, we have OBD, and also we have CAN protocol like an controller area network protocols provide some standards, but there are divergences. So this will make confusion for manufacturers in the perspective which one to choose, what to choose, how to develop. Battery, this matters a lot. Battery is like which and how much, how to operate, because if there is no battery in my device, so I will lose completely access of my device. So secured, and always we have to make sure that my device is able to recharge and it able to get a battery to process. Lossy and constrained network. So constrained means lossy. Constrained means it's like a low power personal area network, low power devices. Constrained network, the controllers or so many sensor devices what we are using are all constrained devices. Which one to make use, and all to we have to make sure that. This is like an yes, the nice, but we are gets tougher. So the nice thing about standard is that we have so many to choose, so many. We are thinking like there are so many challenges are there, but we have so many things to choose in the perspective of an security, in the perspective of an protocols, or also in the perspective of an Internet of Moving Things like an spottier network latency, bandwidth changes, and dead zones. So these are the different things. So we have lot of protocols, lot of standardizations. Which one to choose? So it's like a toughest part while going to build a product. And another tougher part is on security is the topmost constraint, and key management and to has to be very stronger. It may be from the cloud, or else it may be from the embedded device, or else it may be from the application perspective. So to make sure that the user accurate or the authorized user, and also to make sure that the user is able to make accessible for an authorized device. So these are the security is the topmost constraint when we go for any of the product. And devices are in offline territory, like customers have physical access to devices have to work in wind, rain, sun, dust, exposed to elements, all the elements. It is not only car or vehicle like a cycle. It left to all the different products, all the different IoT based devices. It may be a water quality monitoring, it may be an environmental monitoring, it may be an agricultural monitoring. So all that has to be keep on working. It has to be like an very enclosed, and it has to be suitable for an all kind of an environmental conditions. And they are moving as well. In case of an vehicle, so we need keep and track so all the time about the devices. So to overcome these constraints, it imposes on protocol design. So OTA. So we means like Zoom car thing. I've understood. So they need all the time OTA updates, OTA over the air upgrade. So this is very much important. So for any of the product, so OTA upgraded because we may not be accurate at the time when we go to the market completely, not an 100% at that time. So we will understand from the market, we will understand by the users, we will understand from the user requirements. So at that time, we will understand what kind of modifications has to be done, and to upgrade the products which are already in market, the OTA update is required. For that, cryptographically sent, the OTA upgrade is not supposed to be an unsecured. The OTA upgrade, because so many means cyber secured hacking will be keep on hacking because of an unsecured process of an OTA updates. So this is also has to be a secured process of an OTA update to the device which are already in a market. It has to be an cryptographically signed kind of OTA updates. It may be patch command or as a suit working group. Suit is the one of the Internet of Things based software update Internet of Things working group. So it is a well documents to perform the OTA update for an IoT devices. Keys management is an paramount as keys might need to be revoked, logic and command to control on web service and mobile app as a proxy, and one-time use keys need to be generated using TOTP. So TOTP and HOTP. So these two are based upon an OTP form. So this is from the part of an Internet of IETF, Internet Engineering Task Force. So this TOTP and technically OTP, this and HOTP, these two RFCs will tell and completely idea how to create an OTP process in a secure way. And timing and management for update and forced update. So update is not like an anyway time we can do. It has to be from the with the permission from the user, or else it has to be from the push method, or it has to be sometimes it has to be a pull method. So we have to make sure while performing an OTA update, so when we have to do it. So, and we have to make sure that the battery is suitable battery is available to perform, to complete my OTA process. If it get break in the middle, it is going to break the complete process of my system. Fallback in case of failures and acknowledgement. This is more important. We may think like we are going to do an update. If there is any failure in case of an OTA or OTA update, it has to fall back to the previous stage. So where it was. So these are the and we need an acknowledgement after the photo process to tracking purpose. So these are all the major things. Some we have to concentrate on the devices which are already in a market, because we won't be sure that all the devices which are in market are completely accurate. So we need an OTA update, and while OTA updating, we have to concentrate on some of these points. So here TOTP and HOTP, as I mentioned, I remember like a TOTP is like a time-based one-time password. So to get an accuracy, one-time use key, right? Time-based one-time password. In the case of an HOTP, it is an hyper OTP. We will call it as an hyper OTP. So this is one of the standard from an oath, or as oath means initiative for open authentication process.
So it will provide like both 60-second and 30-second time interval options for available dependencies to serve. Okay, in the since I'm talking about vehicular devices, I would like to tell one more protocol for an in case in specifically into an IoT that is called as an IPWAVE. IPWAVE means IP wireless access in vehicular environments. This is the updated technology in Internet of Things, which is coming up for an specifically for a vehicle and to tracking. This is the technology even like Zoom car and all using this. So this is some specific draft and there are specific communications and the difference between them, the versions are there. And the use cases of vehicular 21 networking include navigation service, fuel efficient speed recommendation service, accident notification service. So for vehicle, specifically keeping in mobility, for specifically keeping in the vehicle in mind. So this protocol is designed, this standard architecture is designed, IPWAVE. So IP wireless access in vehicular environments. The use case of V2V networking include context-aware navigation for driver safety, cooperative adaptive cruise to control in urban roadway, platooning in highways, and these three techniques will be important elements for self-driving vehicles. So this is already, this protocol, this architecture, most of the already industries started to utilize and they're using it, and it is the standardization architecture is still developing. The use case of 12V networking area auto updates and mobilization or global fleet route optimization are all supported. As I mentioned, since I spoke with an update, I just want to give three idea because once my device is in the market, what all kind of an updates I can do? There are three kinds. One is like an poll model, span for control with client. Polling, keep on polling. Client initiated update. This is called as negotiated update. Coordinate between the client and server. And sometimes it has to be suitable. We have to check while performing any update which one is suitable. I would either have to go with a poll model, or else if I have to go with a negotiated update, or else I have to go with a push model. So in case of a push model, useful for dump or non-critical devices, forced update. For example, I kept some of my products in market and those devices are working very bad. They have a very major issues at that time. So we are not supposed to wait until the client initiated update, means the polling process comes up. So we have to force some of the devices to get update to be secure. So these three are the major methods in the updating process. Threat model for updates. So threat model is like a stride we will call spoofing identity, tampering data, repudiation, information disclosure, denial of service, evaluation of privilege. So these are the some of the threat models. I won't go. This will go into depth of a security perspective. I won't dig into that right now. More into technical. It will go off. Yeah. Till now I spoke about the mainly into the vehicular network and vehicular how the vehicles, if the product is in a market, how it will get updated, and if the vehicular device, what kind of an architecture design will be utilized. That's good. So now I want to tell one application. So if I am going with a water quality monitoring application, so where all it can be utilized? Is it our thing, the broad way while designing, the broad mind of designing the product? So how it has to be suitable. For example, if I am building water quality monitoring, it's not supposed to be rigid, it's not supposed to be constrained to a specific area. The water quality monitoring, the design has to cover, it has to be very flexible for the applications. So in the very left hand side, we are considering river, dam, lake are the primary sources. So once after that, the water will be taken to the some major tanks like an water sewer system or like in the area main tank. So there also we can perform the what this SN is called sensor node. The sensor node I will come up in the next one more application. What are all the water quality monitoring sensors are available and how it will be performed. So this sensor node will be consisting sensors, water quality monitoring sensors, microcontroller, and the wireless transmission module. From the main monitoring device, it will be partitioned into two more sub water quality monitoring sub tanks. After that, it will be moved to an some to an big scale industries and some to a small scale industries. So because this is an water quality monitoring in industrial perspective. So where all we may need water quality? We may need in textile industries. We may need it in chemical industries. We may need it in different medicine industries. So dyeing industries. So in different when most of the industries are all require the water the to an quality water. So we need to monitor the water in case of the inlet part. So after inlet, none of the industries won't utilize the water as it is. They will refine it. They will use chemicals to clean the water, and they will make sure that the water quality is good, and then only they will utilize for the any of the manufacturing industry purpose. So specifically in dyeing industries or textile industries, once the water is utilized, it is highly contaminated, highly chemicals will be utilized for a dyeing purpose. So those industries are not supposed to release water directly to the river or as a lake or as a pond. So they have to go with an refining process. They have to go with an recycling process and to remove all the chemicals and to make sure then only they have to release that water to an rivers. But nowadays, so many of the industries are not performing this operation, and the industries are because that will cost them more. They want everyone like think like we need good thing for us once after the usage of it. So we don't want to make it clean and throw it just however it is. We will the industries are releasing it to an sorry the industries are releasing it to an river. So this is what happening where the government sectors and all concentrating on it, and there we need this kind of a sensor nodes. These sensor nodes will take care of water quality in the outlet also, and it will tell the quality of the water, and it will update to the station, and it will perform the analysis. And the things has to be done. The outlet water, what will happen in industries, or so it may be small scale industry and big scale industries. The outlet of water will be utilized for an agriculture, and the outlet of water will be recycled and utilized again for an industries. So in all the scenarios, we need an sensor node. So all the sensor nodes will capture the data and will throw to the base station. From the base station, it will go to the cloud. So here the architecture, here the design is trying to tell the implementation or the product design. It has to be flexible. It's not supposed to be in a unique. I'm going to monitor the water only in a certain tank. No, it will. It will be like it will be major. It will show the major impact on later on. Because what are all the investment we have done, the same investment we have to think in the perspective of how it can be flexible, how I can increase my market area. Just last slide, I have shown the thing like an industry perspective. The same thing, if industries think water quality monitoring, if I have manufactured, I'm using some sensors, I'm using microcontroller, and I'm using a wireless communication. We have to keep in mind while designing. So what kind of a wireless communication I have to use? What kind of an embedded system I have to use? What kind of a sensors I have to use? So that I can use these sensor nodes both in industries and both I can make it flexible for my commercial. So this is for commercial usage. So here you can see there is a one in the very right hand side. So many commercial usageable water tanks are there, apartments are there. So I want to do the water quality monitoring in apartment. Nowadays, none of them used to clean the water tanks or anything in apartments. So just want to monitor their sensors and actuators will be there. So all those things monitored will be transferred the data to the border router. So we have to concentrate more on the mesh technology. It may be in an industrial area, it may be in commercial area. So once the data is transferred to the mesh technology, in a mesh technology, it will collect all the data and it will come to the border router. Border router responsibility is to collect the data and push the data to the cloud. That is to be a database. So here the analysis will be done, and then once analysis is done, so the user can access the data using an Wi-Fi or a 3G. Now it is come updated like in 4G, 5G, and GSM technology, Ethernet, IP, cellular networks. It has to be suitable. We have to make sure that the user must be able to access my database, the analyzed database later. I won't go in depth because so many things is to be repeated. Another part, sericulture. Just I want to concentrate one part in agriculture related. I thought like in go with sericulture. So when the product is in a sericulture, I am using here Raspberry Pi. So in the previous slide, it may be an water quality monitoring in industrial or else in commercial. The only here the main part we have to concentrate what kind of a device I have to choose in the deployment area, that is an water treatment plant, sensor nodes, and what kind of a device I have to choose at the border router. In further slides I will explain that one. I'm going to give an idea and then I'm coming to the embedded devices part. So in case of an sericulture part, Raspberry Pi I'm utilizing, is it really required? Yes. So here sericulture plant, in this one we are making use of some of the sensors like a DHT11 sensor is utilized. This DHT11 sensor, the sensor why we have used DHT11, that points, if I go with an multiple sensors in Raspberry Pi, I won't get multiple interfaces, GPIO pins. So I want to make utilize as much as possible less number of GPIO pins. So at the interfacing pin, at that time, so some sensors are multi-monitoring sensors. That is DH11 is one of the same way. It can support temperature as well as humidity monitoring. So this is one of the sample. So we may in market we will get multiple different kind of sensors. So we can go with the multiple sensors. That too depend upon the I have already explained the range and the accessibility, duration, and also the completely battery consumption. Here the voltage consumption will be more because my Raspberry Pi is always completely battery operated. It's not a battery operated, it's like a completely power source from the main source of supply. And some implementations will be not only monitoring. From this design, we have to understand it not only a monitoring, it also be an actuation. What are the actuation process is there? Sprinkler. So some pesticides in sericulture plant, some pesticides they need to they need to put on the sericulture silkworms. So at that time, so they have to make use of a sprinkler. So for sprinkler, the user, it is not a self-decided process. The farmer will be knowing that at what time he has to switch on the sprinkler and switch off the sprinkler. It has to be customized, built in that way. Cooling system and automated alerting system. These two processes will be an automated decision, means the device has to take an auto decision. But sprinkler is not supposed to be an auto decision because based on the weather condition, farmer will be knowing how long to keep on the sprinkler on and how long to switch off the sprinkler process. If it is exhaust, then the wet condition may increase on the agriculture plant. So here we have to provide the two kind of an actuation process. One is, and in the designing only we have to make it like, and one is like a manually controllable and another is an auto controllable. So auto controlling how means DHT11 sensor, the Raspberry Pi
will read the temperature and humidity data. If the temperature data goes above the threshold value, the cooling system has to switch on automatically. If the, for example, if the by any chance, if it is not by even in the presence of a cooling system, if it is not able to bring down the system below the threshold value, it has to go with an alerting, automated alerting system. Means alerting the user. Of course, it may be a visual effect or else it may be an audio effect. So this is like an while designing, it not only limited to a sericulture plant, it may come to a commercial product also. So in kind of a commercial product, bulb, for example, in my room or as for a geyser, my geyser, it has to be daily, like based on the concept like machine learning and artificial intelligence. Daily, I will wake up at 6 o'clock. So automatically device has to, my geyser has to come with a notification. Shall I switch on the geyser? So this is like the way Internet of Things decision has to be taken care. And if the user required, he must be able to switch on a geyser anytime. This is like an two kind of an automated, automation process. That is one is an automated and manual. The single in the previous this diagram is representing a single implementation, single unit. So if I move to a multiple units, same sericulture unit, same each, for each unit there will be a single Raspberry Pi device. So each unit will decision will be taken care by the specific Raspberry Pi device. All the Raspberry Pi devices data will be moved to a base station. It may be a wired or else maybe a wireless. In this case, we have shown wired because Raspberry Pi will support for an Ethernet cable. So if we go with an wireless, again, what will happen? Raspberry Pi is already supporting an Ethernet port. Why to implement again wireless? If it is in Raspberry Pi 3, price will, my BOM cost will increase. If it is in Raspberry Pi 2, the price will be less. And it is okay. I know disadvantage of making use of an wired connection. So thought of going with an wired in this diagram it is represented. If the user, if we concentrate more on wireless, we can change that to a wireless. That depends upon the user perspective. Arduino boards, and to program the board, we may need one IDE, Arduino desktop IDE. So this IDE will support for, we have a specific Arduino IDE which is available officially from the Arduino side. So this complete Arduino IDE will be will support for different operating systems. It may be for an Windows, or else it may be for an Mac OS, or else it may be for an Linux devices, or else maybe some of the ported means optimized, customized one Windows or Linux operating system will also support. So in this one, in this complete, just a generic, I'm mentioning if it is an complete IDE, we have totally 5 kind of different areas. One, the main area is called as a menu bar. So the topmost is the menu bar. So the topmost menu bar will support for an options like to edit or else to file, to create a new file, to close a file, to open new file, and to save the file, sketch, and the tools. If any help is required, help option, we are going to utilize those later on. And the button bar. So button bar will give for an compiling the program, uploading the program, flash for debugging purpose. So this button bar will support. And the main area for my program is an input edit area. This is the part area for my programming. And the status bar. This status bar will tell me what is going on. Is it compiling? Is it done with the compilation? Is it uploading a program? So if there is any result, output, all this information, the status will be mentioned in the status bar, and based on the status bar, the program notification area. The notification area will tell. So if I'm compiling the program, once after the compile, what is the binary size of my file? So, and if I am flashing my program, what is the memory space I've utilized by my program? So this kind of all the information will be provided by the programmer notification area.
It's very user friendly, and just like an instant directly we can utilize this IDE, Arduino IDE. It will support for, as I mentioned, it will support for all the different operating systems. Oh, I have a slide for this. Okay, just I mentioned, since I was showing here, I have mentioned all these things. So the microcontroller is, as I mentioned, it's an Arduino. I'm concentrating right now. So our microcontroller is an Atmel 328. Operating voltage is 5 volts. But the chip, the chip will make use of an only less, that is like an 1.2 to 3.4, 3.3 microcontroller. Sorry, 1.8 to 5.5 voltage for an operating. That is an Atmega 328. But the operating voltage for the complete board is 5 volts. Voltage recommended is 7 to 12 volts. So, and voltage, input voltage limit is 6 to 20 volts. So we have a regulator internally to handle this. And digital input output pins, it is like an 14. 6 is provided for a pulse width modulation output. Analog input output pins are like an 6. So in 6 analog input output pins, we have there are 6 channels and 10-bit analog to digital converters. And DC current per input output pin is 40 milliamperes, and DC current for 3.3 volt is 50 milliamperes. So flash memory, as I told, the programmable memory size, that is like an 32 kilobytes, of which 0.5 KB is used for bootloader. Internally for bootloading purpose, it has to be used. SRAM. So SRAM is like an 2 kilobytes, and EEPROM is for 1 kilobytes. Sample specifications of Arduino Mega, if you want to comparison. Yeah, as I mentioned, so in Arduino there are different kind of versions of an Arduino are there. So Arduino having like an, when we it depends upon the user, it depends upon the application, which application, for which application I'm using, which board I have to utilize. So based on those things, we have to choose the board. So in case of an Arduino, different type of an Arduino board, so the comparison with an Arduino Mega, the physically larger than the other boards. So Mega is the one, and also offers significantly more digital and analog inputs. As I mentioned, if I'm making use of a more number of sensors, I have to go with an high-ended microcontroller board. So that is like one is the Arduino Mega, use different processors allowing greater program size. In the previous one, it's only like in 32 kilobytes. But if my binary file is itself very bigger size, then I have to, of course, then I have to move with an high-ended boards. And input voltage is like 7 to 12 volts, and digital input output pin is 54. So in my Arduino Uno, that is the digital output pin is only 14. But if I go with an Mega, I will get like a 54 digital input output pins. Analog input output pins are 16 in case of an Arduino Mega. In case of an Arduino Uno, it is just an 6 analog input output pins. Flash memory is 128 kilobytes. Here in this case, the bootloader is 4 kilobytes. In our Arduino Uno, that is with an 32 kilobytes, and the bootloader is 0.5. Yeah, 0.5 kilobytes of a bootloader will make use. SRAM is 8 kilobytes, EEPROM is 4 kilobytes. And the clock speed is an 16 megahertz. So this is just a comparison. We have a different kind of boards. Arduino, Arduino Duo, and Arduino Leonardo. So these are the different kind of boards. Serial port and board. This is to get started with an Arduino board. So we can see here, this is an Arduino IDE. How to get started with first time. So for the very first time, if I want to connect my board, how to get started with, I have other slide which will tell you how to connect a board. In the upcoming slide, I have that one. So yes, in the upcoming slide, I have that on how to connect an Arduino board to your PC. So meanwhile, so select serial port and board. Yes, this is very important. Just if I connect my board, automatically it won't get selected. So here, in this IDE, in my menu bar, so I can see the tools. So in this tools part, I will get an serial port. Once I get connect my board, so in which serial port once I connect an USB port in between my microcontroller and to my PC, so one specific serial port will be assigned to a microcontroller from my PC. We have to specifically choose that serial port. This is the very first thing we have to do. So once I connect my board for the very first time, I have to choose the serial port. So here like an COM port like an 12, it may be 1 or as 12. And then after choosing that COM port, that is a serial port for my communication with my board, so to support in backend the libraries, to specifically if I am defining digital pin 10, the digital pin 10 is different in Arduino Uno board, and the same digital pin 10 is different in Arduino Nano or as Arduino Mega board. So that's the reason. So we have to mention which board it is in the list. We can see all the list of all the boards. The ID will support with all the boards like an Arduino Uno, Arduino Decimal, Arduino Atmel, 321. So many different are the Arduino Ethernet, BT, Bluetooth. So all the different Arduino Nano. So all the different kind of a variety of boards all are available in the list. We have to make sure that we have chosen a specific board. These two are the specific important part while connecting a board. Once after these two processes, we are done with the connection with our board. Next, using Arduino. How to make use of an Arduino, or what will happen, how to write a program, writing your sketch, and how to compiling a program. After running the complaint, how to upload the program. Because right now, we are in this slide, we are able to connect our board to a PC. After connecting board to my PC, how can I make use of an Arduino? So for this specifically, so the program part, as I told, just in the input or edit area, we can write our program. I'm going to show some basic programs today. So in later upcoming. So once we write the program in my input area, that is the main area. So later we have to go with an compile option. This is the compile option. It is available in an button bar. So I've just shown in previous slides, there is a multiple bars, menu bar and the button bar. In button bar, we will get the compile option. Let me go back and show. Yeah, here only. So we can see here, this is called as a button bar. So first process, we have to go for a tools. Tools is available in the menu bar. In menu bar, we have to choose the COM port as well as we have to choose the which specific Arduino board. After that, we have to go to the button bar. I have to write a program and then I have to choose the compiling process in a button bar. Yeah, I'm coming back. So once after compiling, so my program, so my status bar at the bottom will show. So the status bar will show me done compiling. Compilation is completed or not. So it will show the done compiling. So in below the status bar, we added one more part called notification area, program notification area. There it will tell if there is any error, if there is any specific results, or as if any bug in my code, in my program, in any compilation errors are there. So those will be mentioned in my program notification area. If it is everything fine, went fine, if my program is good, then compilation will be done. I'm ready to upload my program to my microcontroller. So for that, again, we have to make use of a button bar on top where we have used the compilation button. So it's just easy. Upload option will be there once we give the upload. So in this time, when we give an upload, TX and RS flash on board. Just make note of this. I will show on board also TX and RX on flash. For while flashing, try it out to blink sketch. Means let me go back to the microcontroller image.
I have mentioned that TX and RX LEDs. So these TX and RX LEDs, while flashing my program using an USB jack, so there will be a serial communication in between my microcontroller and the chip. So by USB to serial IC will provide. During this serial communication, so if it is receiving the program while flashing, the RX LED will be keep on blinking. And for every reception of data, if there is an acknowledgement, the TX LED will be keep on blinking. This makes sure that the blinking of an LED will make sure that I am properly able to flash my program. That is the indication to the user. Once the once after that, flashing a program, so automatically loading is completed. File, sketchbook, example, digital, blink. So there is like a blink example. So on board my LED will be there. It will start once it gets start to run. So after as soon as I flash my program, once it's done with the flashing, my program will get start to run after loading it. So the blinking of my LED on board will get start. It is a simple process. So this is the complete process to connect a board to my PC and to flash a program and to write a program and to flash a program. It is very user friendly IDE. Arduino IDE is the one. Till now, what we have understood, it is the basics how to connect a board. What are all the steps to be used to flash a program to my board? Right now, so input output. So it is like an Arduino microcontroller board. How the circuit has to be there. Just I'm trying to give the complete end-to-end view. So right now, I've shown this is my Arduino board. The Arduino board is connected to my PC by making use of an USB jack. So if I want to make any circuit, we must make use of a breadboard. This is highly suggestible. If we won't use breadboard, there is if I directly connecting wires, loose wires, so there will be a lot of possibility chances to get short in a circuit, and it may damage our board completely. So the bottom one is like an breadboard. So the breadboard will be used to connect my sensors, or it may be LED, or it may be a buzzer, or it may be some resistors. All those things will be placed on my breadboard, and for sensors, the input voltage will be provided from my Arduino board, and the output will be read from the specific part. So what will be the next left side? This left side is maybe an actuators, motors, buzzers. So we can connect those from the breadboard circuit, and input transducers means maybe sensors like any of the switches or temperature sensor, or it may be pressure sensor. So it may be humidity sensor. Different sensors data. So from my application area, this is my application area. The left hand part is my application area. So read the sensor data. After reading the sensor data, we are not supposed to directly connect to an Arduino board, because some resistor circuit is required. The circuit design will be done on the breadboard, and then it will be the output line will be connected to an Arduino. I'm moving into to understand about the digital input output pins, how to define. So just to make understand, microcontroller and digital pins port is okay. Digital input output pins. I'm talking about. I will talk about the digital input output pins. How to, if I want to read some data, how can I read the data? It is the library, or as the programming language which is supporting is very easy. Just if I want to read from specific pin, like pin number 3 or as pin number 4. So for that, how to make use of this programming language is very simple. Just I will explain how to use those input output pins for an input mode and output mode. This pin mode will tell it's a digital pin. In this case, just we have to make use of this function. This is an inbuilt function, inbuilt library function. There is already predefined functions. We no need to write a specific function for this. These are all predefined ones. So for these predefined functions, so for pin mode,
For example, if I am connecting an actuator, I need an output from that pin. So in the pin mode, I need output at that time. So we have to, one thing we have to make understand here, the pin mode as it is we have to use. After that, in the place of a pin, we have to give the pin number. It may be the pin number may be like in 4, and the mode will tell the pin number what I defined, will it be an input pin or as an output pin. And then it is case sensitive. We are not supposed to make use of small letters for an input or output. It has to be in caps. So all the characters has to be in caps, output or as an input. If it is you make use of a small letters, it will take it an error. It will end up with an error. So we have to make use of and to define any pin. Is it an input pin or as an output pin? Just pin mode, pin number, and mention the mode. In a as it is here I am showing it has to be in a caps. After that, so digital read. So I have defined the pin. So pin number is an input pin or as an output pin. So I want to keep on changing the status. Digital read. Which digital pin? Is it like an digital read pin? Is the high or low? So digital read. If I want to make it active, digital read which pin? So that pin I have to mention that number, and then digital write. Digital write will tell the specifically. For example, if I want controlling some LED, so I have activated the pin mode. The pin number is like an output now. So pin number 4 I have considered. The pin number 4 is an output pin because I am connecting an LED to that one to blink an LED. Now, so read what is the status of the pin first. For example, it is I want to know is it glowing or not. So if I read if it comes low, okay. If it's not. If it is in a high or as a low state, I will get to know. I want to change the status. The pin number 4, if I make it I, at that time the pin number 4 will go I means I'm glowing an LED. I will switching on some function. So I'm glowing an LED, and I can give some delay or anything. Later on, if I want to make it switch it off, so I will make it the same function, digital write pin low. So digital write pin number will be 4I, digital write 4 low. So this is very easy. So these 3 steps will be used just to write or just to make use of a simple GPIO pin. So pin mode, these are all inbuilt predefined functions. Electronic stuff. Output pins can provide 40 milliamperes of current writing I to an input pin installed a 20 kilo ohm pull-up resistor. Okay, so here we have to make use of a pull-up resistor, pull-down pull-up resistors. Output pin can provide 40 milliampere of current. So as when we define it as an I, so digital write for out. For I as with an output pin. So at that time, to an input pin installs like a 20 kilo ohm pull-up resistors has to be utilized. Yes, the next part is like a delay part. Where delay will come, just I will mention. Consider this function. These functions are I'm using to glow some LED. LED may be some any application. It may be to indicate or as to notify a user, to red light indication, or as a buzzer. It is a siren. My temperature have reached the threshold value. I have to give a siren. So for that one, I made like a DPO pin as an output and read the status, and then I made it I. After making I, so if I make it I, it will be continuously keep on. If it is a buzzer, it will be continuously making sound. I want to make it like an bit by bit, like an beeping, or as like an blinking of an LED. At that time, what I have to do, I have to give some delay, and then I have to make it low. Means I have keep this it in a loop. I delay and then low. Again delay, come back, and again I. So this delay process, this delay will also be supported in Arduino with an predefined functions. This delay can be defined in an milliseconds as well as for microseconds. For delay in milliseconds, just the function, predefined function is delay, and the milliseconds, how many milliseconds are required, we have to just mention the number. And if it is in delay with respect to the microseconds, so for that also, as you are sharing, so just the predefined function delay microseconds and the number of microseconds, how long I want to make it delay my process, like it is like a sleep mode, sleep. So delay the process, delay microseconds, and the number of seconds has to be mentioned. So similar as like making the process to sleep for certain period of time. And also we will get so many other functions. It's like for an Arduino. So just now we have seen digital read, write, and the pin mode. In the same way we have seen for an delay microsecond. And macros and millis are also available. In the same way, macros of milli, like what is my next function? Okay. Similar to a digital input output, we have an analog input output, same functions. So in this case, it is a digital read. In case of an analog, it will be an analog read. Same, in the place of a digital, it will be an analog, all small letters. So, and also for an digital write, instead of for an analog, it will be an analog write. Say as it is, analog will be in a small letter, and the format will remain same. The syntax for an digital write or a digital read, what we are using, same will be syntax will be replicated for an analog also. In Arduino, we will get multiple. I hope you are able to see my screen still. I've jumped. I have get an off for an Arduino website. So there is an Arduino website. So arduino.cc, www.arduino.cc. In this one, I've given the link in my presentation also. So for digital input output and for analog input output, what are all the functions and mathematical functions, and also for a delay, just now what we are random number creation, random and random seeds, and external interrupts and interrupts. External interrupt for an sensor interrupt, or yeah, if there is any sensor get the data, if any my PIR sensor detects some a movement, then it will give it is like an interrupt. So external interrupts, communication, serial communication, and also to if I want to connect USB or USB device like a keyboard or mouse. So this is consisting of these functions. What are all the functions are there? So all for all the boards, for all the Arduino boards, some functions may be supportable in Arduino Uno. If in Arduino Uno USB port is not there, so it won't be useful for these functions won't be useful in Arduino Uno. If you go with an I-ended Arduino board, in those cases it will be useful. Time, delay microsecond, micros and millis. Coming back to my presentation. Okay, serial communication. So serial communication for the previously I mentioned we have to connect our Arduino board to our laptop. The process to connect the laptop is just directly we have to connect one serial cable in between the USB jack to our USB port in our PC. And the information passes in between the computer and Arduino through the USB cable. Information transferred to that is been bitwise. Of course, the binary data transmission will be there in between Arduino and my PC. That will be always, everything will be on 0 and 1. So serial communication. So serial means because data is broken down into bits. So each sent one after the other down to a single wire. So based on the single, for example, how it will be an binary data means if it is an character B, the ASCII character B is sent as like an binary 0, 1, 0, 0, 0, 0, 1, 0, rather than binary value. The binary value will goes in an low, I, all lows, and then I low. So this is how the binary data will be transmitted. Toggle a pin to send data, just like blinking an LED. And you could implement sending serial data with digital write or delay kind of functions. That these functions we are making use in our next slides to program. A single data wire needed to send data, one other to receive. In case of serial communications. This already I've mentioned. This RX and TX part is for an. It's very important. Some of the board, if it is not working, we won't get to know. We will spend a lot of time without a proper observation. So compiling after that uploading, and as the two LEDs near USB. Already I've explained this part. This will be the process where we'll mention visual effect will be provided user to make sure that we are able to flash the program properly. Next, the one more part, I am able to flash a program to my microcontroller. Just till now, we have seen how to, sorry, till now we have seen how to program my micro by making use of an Arduino IDE and how to flash, how to upload my binary program. After that, if there is any, if I am reading a sensor data and if I want to see the sensor data, how can I read the sensor data? Where can I see the sensor data? For that, in microcontroller in Arduino IDE, we will get in support of a serial port. So we have to look into the serial port. The serial port will available again in this is in our button bar. So compile, upload, and the serial monitor. So serial monitor is also available in button bar. So once we click on the serial monitor, so we will get new screen, and in this new screen, so we have to make sure that this baud rate has to match in between my microcontroller, what we have fixed and what we have assigned here. If this baud rate, if there is no match in a baud rate, these wordings won't be clear, like allowed. It will look like some garbage value, garbage data. We have to make sure that we are assigning a proper baud rate. In our program also, we will assign a proper baud rate. Yes, that is there in the next slide. Just I'm showing here. Serial begin 9600. This serial begin 9600 is the baud rate. Okay. So I'm coming back to the previous slide. So to see the output of my program anywhere, we have to make use of this Arduino IDE and the serial monitor tab. In the serial monitor, we will get a new screen. In that one, we have to assign the proper baud rate to see all the output of my program. Some more commands like serial commands. So these serial commands, so specifically like to assigning the baud rate and also to assign serial print and also the value serial data read. If I want to read my terminal arguments and also to write some data, and also for other functions like we will see those in application in our next programs. But serial baud rate is the very important. That is for an communication between my PC and to my microcontroller. Arduino code basics. So commands and other information are sent to LED, a motor, from sensor through digital or analog input and output pins. So consider this is like one of the sensor. So for this sensor, most of the sensor, the three things are required. One is an VCC input and the ground line, and from the sensor there will be an output. So in this case, so we can see for a sensor the input and ground has to be given from the microcontroller. Just make sure that if your sensor need higher voltage above 5 volts, what can we do? If for example I'm using one sensor, if the sensor requires 12 volts, I'm not able to give a 12 volts from my microcontroller. So in this case, what we have to do is we can get of course we will get an power source from external power source to my sensor voltage, and every time make sure to keep the ground line common short in between your power source. So power source 12 volts, power source additional you will connect to your sensor. That ground line from the external power source ground line and your microcontroller power source ground line has to be shorted. Make sure that all the ground lines are shorted connected each other, or else you won't get the proper data. It won't be in sync. So if the voltage is below the, if it is voltage is 5 volts or below 5 volts, we can get it access from the microcontroller itself. Adding an LED. How can we add a LED? So this LED part is like similar. So we are making use of a ground line. So one is like a ground line, and for an LED to blink, so one line has to be an by making use of a breadboard. So one line will be a ground line and one will be a VCC line. So here we have to control our LED buzzer or anything that will be like an actuator. At that time, so one side we are giving to a ground lines to my LED, and another side will be given from the digital lines. The digital line we are making use of resistors. Resistors why we are using means if we are getting some 3.3 voltage, and if to avoid if they need damage of my LED, if the voltage is high, so it may get damage to my LED. To avoid that part, we are making use of resistors. Now the coding part. Arduino programs run two basic sections. If you go to any program, it will be consisting, these two are the main basic section. One is the setup section and the loop section. Just remember these two, without these two sections, you can't run your program. So two sections are in any program, it may be any IoT application, it may be anything in Arduino. The two setups functions are like, one is the setup and another is the loop. Setup section is like a user for assigning input, output. For example, if I'm making some sensors, temperature sensor and all, I want to, it is like as the name itself tells, it is for a setting up. It is to set up which pin I have to use to read the sensor. It is like declaring the function, declaring the variables, declaring the all the required GPIO pins. So declaring if I want multiple variables, if I want declare the specific GPIO pin, all the declaration will be done in the setup part. Okay, here I'm explaining what is again the setup. The setup section is used for assigning input and output pins. Yes, that is what is declaration. Example, motors, LEDs, sensors, etc. To ports to the Arduino. Ports means the GPIO pins. It also specifies whether the device is output or input, and the pin mode. We use the command pin mode. Which mode? Is it an input mode or as an output mode? This kind of a declaration will be done in the setup part. So you can see here now, this is an example void setup. So in setup, pin mode, the pin number 9, already I explained this predefined function. So pin number 9 is the is used as an output pin. So no need to add any additional things, or else no need to write any additional function for pin mode. It is already predefined library function. So the next part is I have coming back to this is the define. I have kept the setup. What is the setup? For pin number 9, I am connecting an LED. Consider this is your LED. You want to blink an LED. So pin number 9, that is an output pin. I have given the setup. Next part, I want a function process. So in a loop, we will perform the function or else any process. So in loop, what I am doing, digital write 9i means for the pin number 9, I am making it I, means I am glowing that specific LED, and I am giving delay for like an 1000 delay. It is as I mentioned already, delay is in 1000 means it is like an 1000 milliseconds. If I want it in a microseconds, then it will be delay microseconds in brackets 1000. So two inbuilt functions, all are input functions. That's why Arduino is like a pretty easy to develop any application. So very fast because of the inbuilt library functions which are already available. So just to control my LED, digital write 9i and miss the pin number making high, delay and make it low, again delay. This is a loop. So because of the loop, it will be continuously running. Variables. So variables is like a pretty known thing. So variable means is like a bucket is a placeholder where it can hold number or as a string or as a float or as a double value, integer or a character, anything other values temporary for a certain period of time. There's a variable. It's with a specific the variable that will be consisting in a specific address. How to declare a variable in C? So to declare a variable is also very as like similar to in a C program. There is a C programming integer. If it is an int, define the type data type. Int if it is a float, or as if it is a character char. So just define the data type and the variable name. Assignment becomes and value. I will show in the next slide how it will be defined. So the task replace all delayed times with variables means it's a good habit in programming. So it is not an what we are using the pin number 9, right, in this previous example. So if I want to change it for an pin number 10 or after certain period of time, after few days, so it is very tough. I have to search the whole program where all I have used 9. I have to keep on searching and then I have to edit. So the good habit of programming is like replace all the delay times with variables and LED pins numbers with variables. That will be like this. So int to integers, we have to declare the delay time variable. Why delay time means what all the integers means one will be the delay time and another int, the data type int is for an the pin number green led 9 or and the delayed int delay time 1000 int green led 9. So at that time, if I change in my declaration, if I change it for 10, that is good enough. It will get reflect everywhere. So this is how we can declare our own variables. So using the variables. So in the same program, so LED controlling just an LED or as some buzzer. So to get started, like an hello word or as an LED to get started with is a good program. So I suggest to go with this one. Once after this delay time, if I want to subtract 100 from delay time to gradually decrease LED blinking speed. So since it is in a loop, so all the time the 100 will be keep on decreasing from the 1000. So the delay time minus 100. So this is how to can be utilized using the variables. What about the conditions if I want to make use? To make decisions in Arduino code, if we use if statements are based upon true or false question. So it is like very similar to an C program, true or a false condition. So what kind of an conditions we may use? Value comparison we may use. So is it as an greater than or equal, less than or equal? It is A is equal to B, A is not equal to B. These are the some conditions. First come to the if condition. If true means if A is greater than B. What is the condition? Just now I shown these are the value comparisons. If A is greater than B, yes, if it is true, perform some action. If A is not equal to B, perform some actions. So if it is false, it will skip, it will go to the next. Okay, this is some example with an if condition. So in serial void setup, as I mentioned, two functions are by default. One is an setup and another is a loop. In a setup, I'm giving the baud rate 9600, and then void loop. In a loop, the counter. So print line the counter serial print. So just I'm counting and just I'm printing. So it is an example to check the condition. If counter is less than 10, so print this line, print the counter number. What if it is a task? Task means create a program that resets the delay time to 2000 once it has reached 0. That is a task. Means delay time to resets the delay time to 0, because in a previous one we are reducing the delay time from 1000 to 0. In this time, consider the time incrementing. For example, from 1000 to I'm decrementing to 0. Once it reaches to 0, I have to make it reset for 2000 or 1000 once again. This is like a task. How can be performed in a task? And also input output. Consider transferring data from the computer to an Arduino is done using serial transmission. To set up serial communication, we use the following. That is a serial begin. So previously also I mentioned the one baud rate like 9600 is the specific baud rate we have to use. So in the same way, while transferring the data in between computer to an Arduino board, means any communication in between Arduino as well as the PC, we have to make use of the serial begin. So simple application. So these are all declarations. So I am declaring the things like one is the serial begin is my data rate. So that is 9600. After the serial data rate, I am giving us a serial print. That is a serial print to like a print line hello world. In void there is nothing to process. So I'm just void loop must be there. It is an empty. It will just print an hello world once. Okay, modify your traffic light so that each time a new LED is illuminated, the console displays the status of the stoplight example. So this is like some application example. Try by yourself on programming. So, but these are the sample applications. So this is like wide setup, serial port, allow word, or as what we have seen till now. So glowing an LED. So you can try with multiple LEDs. So I suggest, it is not like in a task means it is, I suggest to try this one. So today that will give an idea how to control multiple. If you have any doubts, let me know later on tomorrow. So I will help with that. So we have to see what is the output voltage and what kind of an LED. In LED, there are so many different kind of an LEDs are there. So LEDs like an so 2 mm, 3 mm LEDs are there. So for each LED, how much the current and how much the voltage it will consume, it will accept as an input. We have to check. If my voltage is more, or if my current is more, so we have to reduce that one. But based on that one, we have to calculate the resistor value, how much the value we have to utilize, and we have to make use. It is not like in any predefined or as the standard resistor value we have to use. Some of the important functions I would like to cover here. So important functions like an serial print line, the value. So we are already seen the serial print line, that is to print the value. It may be any sensor output, or it may be any debugging for debugging purpose if you are given. So print the value on a serial monitor. So we can make use of a serial print line. Pin mode, digital read and digital write. We have seen all these three right now. Outline. So yeah, the next one I'm going with a delay, infinite loop, and polling or busy wait or input, output, interprocessing, timers, code transformation for embedded computing like an unrolling, merging, peeling, tilting. So delay. So I will go with this with some examples. These are all with an application examples. So delays are essential. So we have seen already two kinds of delay and delay millisecond. So delay millisecond already explained. So creates a delay in a millisecond and a microseconds. I'm just going past cover. Okay, and do we build a delay function? So we don't want to build any specific delay function in that one. In this case, we use a register or a timer to measure the number of ticks. So if it will be depends on completely based upon the application. Our reference is the system clock frequency. We have on board crystal. So based on the system clock frequency, we will check and our system will work on it. For example, assume 16-bit processor and increment and jump instructions to one cycle each every time. and 10 megahertz system clock call build a 1 second delay. How it can be done? So this kind of completely depends upon the system clock frequency. So for example, if it is an int I is equal to, it's like an 50 lakhs, so 2 ticks per iterations, so then I have to decrement it. If it is not equal to 0, go to back. That is like as like similar to go to is predefined, is not suggestible to use. Even in C programming also, it's not a recommended one to use. It will give us some error. Infinite loops. Do I have example for this? Okay, embedded systems are mostly single function, so their core, yes, because it will be not consisting in multiple applications or multiple things. So their core application never terminates. So infinite loop are not forbidden as long as they are done correctly. So how it can be done? So in this case, for example, I am defining an enumeration. Light is the enumeration, and then red, orange, green, the 3 LEDs. I'm keeping that it in a loop with a delay. So one after the other LEDs has to keep on glowing. So just this is like a main function. So these red, orange, and green, the pin numbers has to be defined, and it has to be assigned as an output. After that one, LED is equal to red delay, and light is equal to orange delay. Means for every few seconds, it is like an blinking process. It is toggling. Yeah, it is like an toggling. First time it is, if it is an I, it will go to the low next time when it is called the loop. So it will be like an infinite loop. Because here goto is considered a bad program, as I mentioned already. Goto is not a suggestible, it's a very one of the bad programming process. So in order to avoid the label, Arduino provides an infinite loop function. This is the infinite loop function. So light enum, that will be defined in an setup main function where as a declaration part, and in void loop the whole function will repeat completely back to back. So making use of a general input output pins. So embedded processor receive inputs as a microcontroller from the sensors, and it will give the output to the external devices as an actuators. So in this case, these require reading and writing from the single input output port. We have already seen the output port, how to make specific part as like an digital write. So the same, it is explained in detail, in depth. So in C, how it will be performed. C is an high-level programming language. It is the same thing is used here, useful for why we are using the same thing is useful for accessing low-level assembly functionalities for high-level language, and simplifying desirable embedded system functionality that is considered a bad programming practice, such as infinite loops. Essentially, functions are functions the user calls, generally machines and compiler dependent. It is possible to write an equivalent function for another machine. We'll see that one in this is a basic of an C explanation. We'll see it in the next example. Yeah, this will give idea. Example for an Arduino. Consider now this void loop. This create an infinite loop without the programmer using to go to, which is a bad programmer practice. One thing. Second thing, this digital write 7 high. So 77 high. This turns the 77 pin high on and off. Means if it is a low, it will be off. Assuming there is something like an LED there without using logical instructions, because microcontroller won't get to know what is connected in the external. It is maybe a motor, it may be a stepper motor, it may be a DC motor, it may be a buzzer or LED, or and even what kind of an LED, the brightness, the LED, so many different kind of LEDs will come out. It is based upon the brightness and the size and all. So the standard output will be given from the microcontroller, and the delay 500, this creates the off second 500 millisecond delay without directly accessing the timers. And this is the complete program example to try it out. What I've explained, the same thing. So the same thing we can see here. I have mentioned, you can observe from the beginning, I have mentioned even earlier. So two functions are must and compulsory in case of an this in case of the programming. One is an setup and the loop. The setup is for an predefined, so we can see, and the word blink one, so blink an LED once back to back. There is a continuously loop using switches and buttons. Till now we have seen most like a digital write switch or a button. It is like giving an interrupt. So, for example, if I come and press a button, it has to give an interrupt to my microcontroller. Once my microcontroller receives an interrupt, it has to give some siren, or else it is like a calling bell. If I press a button, the interrupt will come to the microcontroller. Microcontroller will start making some process. So switch and buttons are considered like an input data. So I don't want to make it change anytime, all the lifetime of my program. It has to be the pin number by any chance is not supposed to get changed. That's why I'm making it as a constant, the variable, and integer input pin 2. After that, void setup. I'm setting up that pin, input pin, either it has to be an input or an output. Pin mode, input pin, the variable is already declared, that is 2, and these uppercase letters, once again I'm just repeating, make sure that input, or as if you mention output in the pin mode, input or output, it has to be always uppercase letters. By mistake, if we mention small case letters, it won't support. Then the void loop for a continuous operation of reading the data. So since it is in a loop, it will be continuously keep on reading the data from the specific GPU pin. If there is any interrupt, it will get triggered and the specific operation can be performed with an if condition. So the previous one, what I have shown, it is like an reading and digital data is simple, like an switch and switch and button. In case of an this part analog data, what if it is an analog data? Constant variable pot. Pot means here potentiometer. So it may be because potentiometer, it will be very pretty used like to change the value based on the resistance. If we can make use of an any other sensors also, temperature sensor, or else we can make use of an any other different sensor, pressure sensor, any sensor, light intensity sensor. So reading analog input and scaling in this part. So select the input pin for the potentiometer, that is I'm making use of the pin as like a 0. After 0, so directly in a loop, so integer value and integer percent. So this part is to these two are the things, the value coming from the sensor. Integer val means the value I'm assigning to the variable that is read from my sensor. Int percent is the mapped value. First val, that is a value. So val is equal to analog read. So the function name, predefined function, because the data what I am reading, it is an analog data. So I am making use of an analog read. In previous thing, I'm coming back to the one slide back. In previous thing, when it is digital data, we can see here digital read. If it is a digital data, it is a digital read. In case of an analog data, it is an analog read. So analog read, pot pin is 0, already predefined one. Once pot pin 0, it will read the data from the specific and it will assign to a variable, integer variable, that is an val. Now the voltage on the port is ranges from 0 to 10 to the maximum. Now I want to see the percentage in the range of 0 to 100. For that, the percent means what is the percentage in between 0 to 100%? For example, if it's like a temperature sensor, what is the percentage in between 0 to 100? So I have to give the mapping process. The value is the data which is read from 0 to 1023. it has to be mapped in between 0 to 100. For that, inbuilt library function map will be used. This map will provide an in the percentage value what is the accurate percentage in between 0 to 100. So the later on I can print the percentage value, percent. Next, I have one application that is an like an LED graph. Um, this one LED graph, I will explain this one by making use of a multiple LED. So you can try this one. Number of LEDs are using year 8. I'm keeping the number of LEDs like a number of LED pins like an in a 70, 71, 72, 73 like an numbers I'm defining. Analog pin, analog input pin, that is a constant, all the constant variables that is like an 0 is my analog pin, weight is equal to 30, and boolean LED on, LED off, high and low. Now the sensor value is 0, and then my sensor value converted into LED bars will also be 0. These are all the predefined, these are all the variables that I am just declaring right now. And then in setup, I'm just putting a condition. If I is equal to 0, and if I number of LEDs, if it is I0, I is a variable, if it is less than number of LEDs, increment it. Pin mode. So in pin mode, what we will define in pin mode, we will define the pin number and then the either it as a input or output. So in this case, I'm just making it in everything in a single function. So this pin LED pins array I, if it I is 0, so already in the second line I have defined, if it is in 0, then it is 70, pin number 70. So then pin mode 70 output. Next, when it comes up, it will increment because I++ is there, it will increment. Post increment will happen. Then next part, LED 71 output, 72 output, 73 output. So this is like a graph creation, just an incrementing LED by making, this will shows the making use of an for function and declaring in multiple variables in an Arduino board programming. And then the rough continuation is like reading, as I mentioned, we have already defined the read the value from the sensor. Now, sensor value for that analog read, already we have used this analog pin number is already defined, that is a 0 pin. So read the value from the sensor value, and then after reading the value, because there is an analog value, just now we saw with potentiometer. Since it is an analog value, convert the analog value, means map it in between 0 to number of LEDs, how much, like an 7. So in between 0 to 7, sensor value, the sensor value reading is in between 0 to 1023, and then map it for a number of LEDs. So based upon the sensor value, number of LEDs will be glow. If it is 3 LEDs will be glown. If it is 4 LEDs will be glowed. If it is total like a 7, if it is like a full sensor value is maximum, at that time it will be like an LED value will be 7. So number of LEDs will be 7. So LED level will be 7, and here we will glow all the LEDs, 7 LEDs. This is like a graphical representation by making use of an LED. What is actually Raspberry Pi? What all it consisting, and what all we can do with a Raspberry Pi? So Raspberry Pi is like pretty well-known, very famous device if it comes to an IoT, like Arduino, Raspberry Pi, and all buzzwords. So Raspberry Pi is like a series of small single board computer. This is developed in UK. The vision or as the mission of the Raspberry Pi Foundation to promote for an teaching of basic computer science for school students and in the developing countries. Raspberry Pi is not developed by keeping the intention of an IoT or anything. They want some device which can operate as like a computer, and for the basics, like to learn the computer science for the students they wanted to develop, and this board have come up. The original model became so very popular at the beginning, and they started to making use for robotics, and it, even though it don't have keyboard and a mouse, we can connect to a keyboard and mouse, and we can make use as like a computer, and so many advantages we had. So once this Raspberry Pi came to a market, so it was released in 2015, yeah, I think, yeah, in 2015. So from the year 2015, like an yearly, the sales, the usage of a Raspberry Pi is ridiculously keep on increasing. So in around 2017, as I read somewhere, it is like an 15 million devices got sale, and in till the March of 2018, the sale have reached like a 19 million. So 19 million Raspberry Pi device have sold out. The most Raspberry Pi device manufactured made in a Sony factory. The Sony that is in Pencode Wells, and also some of them are made in China as well as Japan. So they are the copy guys very well. So this China and Japan, some boards we have to, while purchasing the board, we have to take care very well. So some of the boards are duplicate, we won't get to know, and the boards will get damaged so fast. So affordable, this Raspberry Pi is like a credit card size computer, we can call it as like a computer, and plug into a computer monitor or a TV, use standard keyboard and mouse. What are all the peripherals? We'll look into that in next slides. Can browse the internet and play HD video, and I can play a game, I can watch movies, I can just listen music, I can capture the video as like my laptop from the webcam. How can we perform the same way? And can also interact with the outside world. Outside world interaction means it is because of an internet. So it have very well Ethernet port, and now the Raspberry Pi 3 have support for an Wi-Fi, and the Raspberry Pi 3 will support for Bluetooth. So this is just basic. So Raspberry Pi Foundation, when coming to the Raspberry Pi Foundation. So the Raspberry Pi, the organization behind the Raspberry Pi consists like mainly two arms, and the first model was developed by the Raspberry Pi Foundation, and there are different models are there. After that, the model B were released. The foundation setup of Raspberry Pi from the specifically the UK, and the model B came, the model B plus came. So we'll see what are the different kind of models that came into the market. So the foundation goal is to advance the education, as I mentioned, of adults and children in the field of computers and computer science related to subjects. It is not in the meaning of an IoT, but it got very popular whole world. Why was the Pi created? The same is like, as I mentioned, in 1990s, the main vision or a mission to develop this Raspberry Pi is to educate the students. So for the computer science students, and to make it as an obvious to programmers, where they can utilize this mini computer, the credit card size computer for programming. The 2000s were very different, and typically where applicant many may have only done a little web programming parts, and also a different application process, and even for a robotic purpose. So these are all the different kind of Raspberry Pi models. We can see here the Raspberry Pi, after the basic one, we have different models. So Raspberry Pi B, revision 1 links, Raspberry Pi A, revision 1, 2. The major changes is like in the memory size, GPU size, and also wireless communication size. Chinese have their own different, like in revision 2 Chinese, we can see different Chinese boards which are in red color, and computer module. And also the Raspberry Pi Zero became very famous, the cheapest one, the Zero. But that's, as it is, the price reduced. So the peripherals on that board will also be reduced. So Raspberry Pi 2B, 3B, 3 computer models are different kind of Raspberry Pi family versions. How to get start with this? To get start, first thing in Raspberry Pi, operating system is required. So for the very first, I have to install an operating system, and I have to configure my operating system for the very first time.
So in case of an Arduino, no need to open any operating system or anything, just directly plug and I can play, I can program, only IDE is required. So Arduino IDE, if it is in once it is in my PC, I can directly program my microcontroller and I can use it. But in case of Raspberry Pi, operating system is must and should, and we must take care, the operating system will be running on SD card here. So we have to take care as SD card not supposed to get crash, or as the voice is not supposed to get crash, because there is no other backup on Raspberry Pi. All the information will be stored on that operating system which is on SD card, and if it get crashed, we will going to lose each and every data. Peripherals for a display peripherals are in webcam and all, and write a program and then make utilize for our profit based upon our application. So we required, we can utilize for our profit purpose. So first, the very first thing is like an operating system. So when to talk about an operating system, the Raspberry Pi have an multiple different kind of an operating system. So Raspberry Pi OS means, if you to see, so as I told, it's like a different kind of an multiple operating systems are there. So the very pretty famous is an Raspbian and Noobs. So these are customized and optimized operating system for an Raspberry Pi. For Windows also, Windows operating system, Windows 10 IoT Core. So from Windows also there is a specific operating system for development of an application and all. So that is called as a Windows 10 IoT Core, and non-Linux distribution is the RISC OS, and also RetroPie is there. That is different operating system OSMC as well as Rebasic and ARM as well as Pydora. These are different, like in Snappy, Ubuntu Core, Ubuntu Mate. So these are the different operating system, but from the Raspberry Pi Foundation, the official supported to operating systems are like Noobs and Raspbian. So we are going to work either with Noobs or in Raspbian. So many SD cards are available in market direct with an Noobs already pre-installed. So installation is very easy. It won't take any complicated, because we must know how to flash an image, how to store an operating system to an SD card. Then only it will be easy for any further to utilize it. Installation process. Get a SD card micro for newer Pis. In a previous, like an older version of an Raspberry Pi, it was not a micro SD card, the bigger size of an SD card, but what are all the Raspberry Pi B plus 3, Raspberry Pi 3, all these Raspberry Pis will support with a micro SD card, and I suggest one come to the SD card class 10. So SD card will have different classes. The class will tell the speed of and communicate, the speed the SD card can support to communicate with your processor. So if you go with a lower class 4, class 6 and all, so you will observe there is a lag, or else there is a latency in, if you open a browser in your display by connecting to a Raspberry Pi, the processing will be very slow and it takes a lot of time. So speed from the SD card has to be supported. I suggest for to go with a class 10 Raspberry Pi, SD card for a Raspberry Pi. First thing, once you get an SD card, whatever it is, formatted. We can make use of an online available SD card formatter. So once after the formatter, the official Raspberry Pi website, in that one we can download the Noobs operating system. So this Noobs operating system, as I mentioned, SD cards are coming up with pre-installed Noobs. It can be purchased, but there is nothing, I think, because as we are all developers, we must know how to flash an operating system to an SD card. Just download the Noobs from. It takes some time, like it takes pretty like some 30 to 40 minutes. So download a Noobs operating system from the official website and unzip the operating system and copy all the contents to the SD card. That's it. So, okay, the first thing is like an SD card insert to our PC or as a laptop, SD card slot, format the SD card, download Noobs operating system from the official site, and then unzip the
it will be a zip file. What we are downloading, it will be a zip file. Unzip that operating system. After that unzipping, copy all the contents, what all that in a folder to an SD card, and then unplug the SD card and place it in Raspberry Pi and boot your Raspberry Pi. Boot means power up your Raspberry Pi. That's it, done. So this is very simple steps. So there are some like an disk image writer. This is like, for example, is like some tool already required. So there's an disk image file is available. Write the disk image on the SD card. So for Windows, you can use Windows or you can use Linux and all, and then boot up. So instead of that one, the pretty easy one is like just download the operating system notes, unzip it, and then copy all the contents to the SD card and place it in your place the SD card in your Raspberry Pi, boot it up. It's very simple steps. Okay. So camera kit contents. So some of the additional contents will be there in Raspberry Pi. Some of the additional contents. Raspberry Pi, okay, in this image I am showing the Raspberry Pi 2B, it's fine, but Raspberry Pi 3 will also be similar, but it will be having an onboard Wi-Fi and Bluetooth and SD card, what are all we require. So for an one of the Raspberry Pi means we require one Raspberry Pi, we require one SD card. So for Raspberry Pi 3 and for Raspberry Pi B plus and all, we want to go with a micro SD card. And this one is a Noops pre-installed, which comes with an Raspberry Pi logo. Wi-Fi dongle. For Raspberry Pi 3, Wi-Fi dongle is not required. If it is in Raspberry Pi 2, means if you are working with an old one, Raspberry Pi 3 is pretty costly. So if I am making use of an Ethernet cable to communicate with my Raspberry Pi, then Raspberry Pi 2 is good enough. So no need to go with an Wi-Fi for an additional only Wi-Fi module. By keeping, if I'm not utilizing, if there is no use, it's waste of budget. So Wi-Fi dongle, so if it is required, already Ethernet port will be there. If I don't want to make use of Ethernet and I want to make use of an Wi-Fi, so we can place an Wi-Fi dongle to the USB port. There are 4 USB ports. In the next slide, I'm talking about the all the peripherals of the Raspberry Pi. And Raspberry Pi, yeah.
What is the capacity of the size of the SD card?
Size 4. It is like an 4 GB. That is very good enough.
How much?
4
GB. 4 GB is enough.
Yeah. So
okay.
So some SD cards will come up, like if we go with an 2 GB and all, it depends upon for how many applications you are going to develop. 2 GB is also, operating system won't take more space. Operating system will take a space like very less than nearly like less than a GB, 1 GB. So yes, micro SD cards will start with an 2 GB. 2 GB means it is, if I'm going to develop some videos, if I'm placing some videos and all, the place will be very concerned. Then I have to go with some higher 8 GB or 16 GB. Even we can go with a 16 GB, but whatever it is, 4 GB is like a minimum is required. It's good. On top of 4 GB, 8 GB or 16 GB SD card is also good. But the major point is like class for a communication speed. The class has to be an class 10. Okay, and Wi-Fi dongle as well as the Raspberry Pi case. So since this Raspberry Pi board, we can see it is like an bare completely out, and if there is any single conductivity touch, if I place this board on any of the metal body, so then there will be a possibility of a short circuit and the board may get damaged so easily. To avoid those things, and if by mistake, when I power it up on my Raspberry Pi, by mistake, if even my pen lead, if I touch between 2 circuits, or else by mistake, if any single drop of water fell on my Raspberry Pi will get damaged completely. It is a completely open circuit. So to avoid the damage, we are going to make use of a Raspberry Pi case, and we need a power supply. So, and then on Raspberry Pi camera. Raspberry Pi camera is a completely
standard Pi camera, we will get it in a market. So this Pi camera will come in additional with so many the Raspberry Pis, and the camera clarity will be like an 5 megapixel. It will support with an 5 megapixel. It will support with most of the Raspberry Pis. We will be having an specific port for an on the Raspberry Pi to place this camera. This Raspberry Pi camera from the version of an 2 will support high quality is 8 megapixel. So most of the in market will get an 5 megapixel. We can go with an highest quality of an clarity, means we can go with an 8 megapixel of an camera. That is also from the Sony, and the sensors are designed on board. So we can see the green part, right? So on the green part of a board of the camera, this is the part. So complete the sensors custom design. This is a completely custom design on board for a Raspberry Pi only. So coming to to talk about some peripherals. So what are all there on Raspberry Pi? So what all can be utilized, and how we'll look into the hardware part. First, I would like to talk about a processor. So we are making use of an Broadcom processor. So the Raspberry Pi will consisting an Broadcom processor, BCM2835 system on chip (SoC). So is used for the first generation of a Raspberry Pi. Includes the first generation I'm talking about, that includes like a 700 megahertz of an ARM processor. So later on, we came with an Raspberry Pi 2. The Raspberry Pi 2 is supporting with an the one what I'm showing in my diagram. So the Raspberry Pi 2 will support with an Broadcom BCM2836. So this processor will support for a 900 megahertz of an quad-core ARM Cortex A7 CPU. So this will be consisting in 1 GB of an RAM and video core of an 4th generation 3D graphics core. So this the graphics core and all to play in games, and also to give the animation and all, it will support the processor. So 1 GB of RAM, 4 USB ports to connect my 4 USB ports is to connect my keyboard, mouse, or even for my Wi-Fi dongle or as a Bluetooth dongle. On Raspberry Pi 3 we have on board. If it is in Raspberry Pi 2, so B plus, then we have to go with an additional interface. Full HDMI port. So here we can see the HDMI port. This HDMI port is just directly connect the cable in between your monitor and then the HDMI port of a Raspberry Pi. So once you connect, it will like similar to an your PC, the Linux machine, the Linux operating system. If you have worked on Ubuntu operating system, so the same view you will get on your monitor. So there is no need to add or else install or else any additional packages required for this port to utilize HDMI port. Since the operating system is running on the Raspberry Pi, seamlessly once we connect an HDMI cable in between these two, so we will get a display on our screen. Ethernet port. Ethernet port, so it is for a networking purpose. So the models like an A plus, Pi 0, and these are all the pretty old. Pi 0 is a new one, but it is for a cheap, lower cost, but it don't have any of the Ethernet circuit. But this Raspberry Pi 2, Raspberry Pi 3 and all are an Ethernet port. And Raspberry Pi 3 also have some 10 to 100 Mbps of an Ethernet port, means the data rate which will support is very high on Raspberry Pi 3. And these Raspberry Pi 3, for example, the Raspberry Pi 3 Plus features the IEEE standard 802.11 BGNAC. There is an Wi-Fi standards for to communicate with an Wi-Fi. In Wi-Fi, there are different standards out there. IEEE 802.11b, 802.11g, NAC. So here we can think, we get to know if it is supporting for AC, means it will support for dual band, that is for 2.4 gigahertz, as well as the Raspberry Pi 3B plus will support for 5 gigahertz also, 2.4 gigahertz as well as 5 gigahertz. And the Bluetooth version supported by Raspberry Pi 3 is like an Bluetooth 4.2. Bluetooth 4.2 is the standard supported by Raspberry Pi 3 and gigabit Ethernet. So for an data transmission Ethernet cable, for an wired communication, gigabit Ethernet will be supported. Micro SD card slot that is in the back side of the Raspberry Pi will be there. So in further slides we will see. And combined 3.5 mm audio jack and a composite video. So this part, this where I'm pointing, this card is an audio jack where I can connect my earphones or any audio speakers and all. There is an inbuilt. If I play, there is no requirement of any additional library since we are running an operating system. Camera and display interface. Okay, camera. So this part, so we can see at the back side. Sorry, we are seeing here camera and display composite video. For a display we are making using there is an Raspberry Pi symbol, so backside of a broadcast chip. So this part will be to connect to an display, any composite videos. To get in composite videos we can connect in any of the display. Official, it's available from the Raspberry Pi in video display in the market. So, and the camera part. So next to the audio jack, in between the HDMI and the audio jack, there is a camera port. We can connect the camera. So just in my previous diagram, there is no additional requirement or any interface module is required in between the camera and the Raspberry Pi. Only the strip, the cable, the band. So just we have to place, we can place seamlessly, we have to insert inside of this interface and just directly we can utilize it. Coming to the point, general purpose input output pins, 40 general purpose input output pins. These are all the general purpose input output pins. So this is like an 40 GPIO pins are there to connect sensors, because the Raspberry Pi don't have any onboard sensors. So it don't have any specific onboard sensor, it don't have any specific onboard actuator. So here, this is the general purpose input output pins will be utilized to perform any of the operations like an connecting sensors or else to connect an actuators and all. So there is one more product, as I told, Raspberry Pi Zero. It is can be used as an USB device or as USB gadget. Just for information, let me show that one. Yeah, you can see at the bottom, Raspberry Pi Zero. So the special feature of this one is like a Raspberry Pi Zero can be used like an USB device, as a USB device or as a USB gadget. This Raspberry Pi Zero, as I mentioned, this Raspberry Pi Zero is not consisting at any Ethernet port or anything. This can be plugged into any other computer via ESP port or on each machine. It can be configured in multiple ways. For example, can tell like it show up as a serial device or an Ethernet device, or as although the original A required a software patches specifically, it was added into the mainline Raspbian distributions. To host an operating system in Raspberry Pi 3, we have one advantage. In Raspberry Pi 3, we can boot operating system from USB, such as from a flash drive. Why, you may think, why can't in other? Because in Raspberry Pi 2 and Raspberry Pi 2 D plus and all, we can't boot an operating system from the USB. We can, I think we are familiar, we can boot an operating system from the USB for our PC or for our laptop and all. So in the similar way, for Raspberry Pi 3, we can boot from USB, such as like a flash driven. Why means because in the older versions, there is a firmware limitation is there in the other models. But in case of an Raspberry Pi 3 is the only board that can support for an booting from the USB. This is some of the helpful websites, the official websites, just official Raspberry Pi have its own website. I have given the link. Okay, www.raspberrypi.org. And there are different magazines will keep on coming on Raspberry Pi. you can read information. If anyone have done a very nice project, they can post it in a Raspberry Pi magazine, and bi-weekly online Raspberry Pi newsletter is also there. We will get and keep on information about an Pi weekly. So piweekly.net, Raspberry Pi 4 version of beginners. So many YouTubes like and training and means not training means basics. What if they have done some anyone have done basics of an how to get started with, or as the beginning for YouTube will be we will get here. And one more of my slide is getting added. So the last one is like an Raspberry Pi guide, www.theraspberrypiguide.com. The last one, it is like, yeah, www.theraspberrypiguide.com. So is the one. So these are the like different contents. We will get monthly magazines, we will get an weekly newsletter, and for an Raspberry Pi official website will tell us what are all there, how to access, if any new additional things are coming up, how to utilize these things, the basic get kickstart. So these are the links will be useful. So now to assembling the Pi. So assembling the Pi, here I would like to tell what are all the basic required if I want to get started with a Raspberry Pi. I hope we don't have a Raspberry Pi camera right now. So, but SD card, Raspberry Pi, and the Wi-Fi module. Wi-Fi module is not required since we are making use of a Raspberry Pi 3, and this case is required, Raspberry Pi case. So to avoid any damages, because if by mistake, if as I mentioned, if I place on any conductive material, the Raspberry Pi can get damaged easily. We'll get starting. So just to place and attach an rubber adhesive feet in the Pi case to keep our board. So for like and for longer time to avoid it from any damage, and examine how the pegs inside the case match holes. There are specific holes on the Raspberry Pi board. You can see here it is a pointed. So this we have to. This will. If I develop some any board, if I develop some any robotic project, then I may need to place some conductive material like a screw or as the some glue and all. So this is the hole on Raspberry Pi. The option is place is given for those specific holes. So where I can place, I can connect this Raspberry Pi board into any device. This is the assembling point. So while assembling, we have to make sure that slide a Raspberry Pi into the case on the GPIO squared with the small plastic clips next to the standoff holes. So when we close the case, so we must be able to access for this GPIO pins as well as for the camera interface, and we must be able to have an access for a USB port. So anyhow, this officially we will get in market the Raspberry Pi case directly. So we can utilize it. We will get to know how to place it, and it is specifically designed for a Raspberry Pi only. These cases, no need to go and get design outside. Okay, how to place a Raspberry Pi camera? So this Raspberry Pi camera, the thread of the camera cable into the top of the case, Raspberry Pi case, with the camera facing down, and then the tin contacts is facing up. Here we can see the camera holding interface part. We have to pull it up. We can pull it up and pull it down, the Raspberry Pi camera interface part. Once we pull it up, that is called a camera socket. So here we can see here the strip, what is the camera cable will be there. Once we pull it up, insert the strip and just pull it down, means push it down, so where it can get lock the lever. So this is a simple way of an interfacing an camera, Raspberry Pi camera. This is an official camera. We can't interface in any other cameras. Some USB cameras in market, we will get so many additional USB cameras. So for those USB camera interfacing, we can make use of an USB part. So we can make use of an USB of an Raspberry Pi ports, and those cameras may require additional software, may require additional libraries to operate on Raspberry Pi. Now putting an SD card, as I told, assembling the Pi. two halves of the Pi case together. So insert the micro SD card into the slot on the underside of the Pi case. On the back side of the Raspberry Pi, there is an SD card slot. We have to place an SD card slot. So we have to place an SD card only after flashing the noobs. I just am repeating the steps. Download the noobs. If you face any challenge, please let me know later on while you are doing hands-on. Because theoretically is different and hands-on is completely different. I'm very familiar about that. So we will come across a lot of challenges while doing an theory, means practical. So in theory we can tell, but while doing the practical, the challenges will be there. Sometimes we may miss, while copy pasting, we may miss single file. So we have to make sure that we are not missing a single file and that the Raspberry Pi won't boot at all. So a lot of challenges will be there, and we have to make sure that we are powered it on properly. We can power it on from the USB 5 volts also. SD card, once we download the noobs or as Raspbian OS, just unzip the folder and then copy paste to an SD card and place it on the specific slot of an SD card slot on Raspberry Pi. Now the part is to power it on. So you plug the USB Wi-Fi dongle into the USB ports. So no need in Raspberry Pi 3 not required of any USB Wi-Fi. If we are making use of any Raspberry Pi older versions B plus and all, we need this USB Wi-Fi dongle. After that, plug the keyboard and mouse. This is the way we have multiple ports, USB ports. That we have 4 USB ports. Please plug the USB keyboard, mouse, and all to the Raspberry Pi USB ports. Make sure monitor is turned on and connect an HDMI cable. So HDMI port will be there on Raspberry Pi. So we can connect an HDMI cable in between the monitor and the Raspberry Pi, and then make sure Raspberry Pi is powered on. Don't plug the power supply just yet. Yeah, so make sure that the monitor is properly powered on. And then now the time to power on an Raspberry Pi. On Raspberry Pi, as like in our PC or as in our laptop and all, we will be having one power button. So the Raspberry Pi here doesn't have any power button. It boots up as soon as we plug it. Just if we connect the cable, so jack, so it will boot up. It don't have, okay, I will just power it on and there will be an one button, onboard button, so I can boot up the Raspberry Pi. No. Even so, for some time, if I want to reboot, if my system got hanged, I'm not able to access it. At that time, I don't have any onboard buttons to reset or to reboot Raspberry Pi. We have to go with an unplug and plugging it back the cable for a rebooting purpose. If you have completed all the previous steps, means connecting the monitor and all, then plug in the power supply directly, so the Raspberry Pi will start to boot up. It is similar like an PC. So Noobs Raspbian OS, as I told, Noobs and Raspbian OS are the two operating systems supported from the ARPi. So if we want to know what is the main, like how much the space, how to download, just as I've given the link. So from the official link, raspberrypi.org.com, so from the official website, we can download it directly. So once we download and place it in SD card, the SD card that comes up with a pre-installed with the Linux Raspbian OS. So Raspbian is the fork of another Linux distribution called Debian, which is then customized operating system of the same Linux. Okay, now how to log into the Raspberry Pi for the first time? This is via serial access, but if you are going with a monitor, if you are going to access the Raspberry Pi with a monitor, then directly you will get a screen and display. So you won't see the password as you type it. Yes. First, once it started to boot up, you will get all the commands, like, and this is the boot up commands. So what are the starting the server, NTP server, and also OpenBSD secure system, and all GNS Linux. These are all the print you will get. Then it will ask for a login. So Raspberry Pi login, the default is like by default Raspberry Pi standard. By default, login name will be Pi and the password will be Raspberry. These two are the default. So if you want, you can later on we can change it. But for the very first time, so all the operating systems, once you flash,
these two this is the credential, default credentials, Pi, and the password will be Raspberry Pi. In this case, while entering the password won't be visible. Just we will be keep on entering, but it won't reflect on screen. So we have to make sure that we have entered the right password and just press enter button to just get in. So after this, we are able to access my Raspberry Pi. So once I'm able to access my Raspberry Pi, if I want to make some configurations, so what all the configurations can be done? So configurations, hands-on configurations of the Pi is like in configuration of an Raspberry Pi for the very first time is after launching. It's not mandatory to do, but it is maybe required sometimes. So sudo raspi conf iphone config. So this will give the configuration options. So what are the setups options are required? We can here you can see the change password, the second option, expand file system, ensure that all the SD card storage is available on the OS, and to make sure that all the if you are doing the copy paste, to make sure that all the SD card storage is available into the operating system. And if you want to change the password, the default password for an Pi is an Raspberry, so you can change the password. And enable boot to desktop scratch. Choose whether to boot it from the desktop environment or as a scratch or the command line environment. If you want like a desktop, it will be visible like an Windows. Sorry, it's not on Windows. It's on Linux, Linux, Ubuntu, or as in Fedora kind of. It will be visible. Operating system. There is an GUI. Internationalization options, set up language, regional settings, and enable camera. So here we have a direct option for to enable in camera. Enable this Pi to work with Raspberry Pi camera directly. All the inbuilt libraries are supported, and the demos will be supported. Add to Rastrack, overclock, advanced options, and about Raspberry config. So these are the options supported in Raspberry Pi by default. We can start to go with the screen, the options screen. So sudo space raspi -config. So as I mentioned, we can change the language, we can change the keyboard format. That we can change the local time zone and change keyboard layout. So we can choose different whatever the configuration is required, and we can make it choose the appropriate user appropriate keyboard format. Which one is required? Is it an US or any other? The language configuration. This is just a configuration part I'm just showing up. And after that, after the configuration, choose the default whatever it is, and then setting special command keys for the keyboard is like select no for the Control Alt backspace command. Means how to choose yes or no. So after all the configurations, either to save the configurations or the not to save the configuration, we have to. The options are available on screen only. You can see use Control Alt backspace to terminate the X server, or else not to terminate. You can use there itself. The options are visible. Enable camera. Okay. So enable camera is pretty required. If I am making use of an Raspberry Pi, for example, like some camera to monitoring like an parking slot, or else to monitor some any application to monitor my area, working area always. So camera will be used in those cases. We can't use like an Arduino board and all. Arduino board and all can capture image, but it can't give you the continuous video live streaming. So, but Raspberry Pi is the one device which can provide the live streaming. It depends upon application, what we are. If I want an image only, serial camera with an Arduino is good enough. But if I want to with an continuous live streaming, enabling a camera, so the library daemons are completely available on Raspberry Pi. So in this configuration, enable camera and then enable support for Raspberry Pi camera. You have to enable it, and so those options will make you available, and then set up automatically boot to GUI. This option will tell you once I boot up. So on even though if I'm connected to a monitor, so do I need a graphical interface, or else do I need a command line interface? So desktop environment means as like we'll get lot of options on the graphical options, and we will get a browser option and all. But in case of an command lines, so we have to work on command line everything, like by even just to log in, including a login screen. So as we have seen previously for login, so we are given the username and password. But in case of regular in day-to-day life, we will get a graphical representation. All these configurations can be performed. Just I'm moving a bit fast. So this is the basics, like how to boot up and how to start with an Raspberry Pi. So to reboot, yes, even we will get an option. Would you like to reboot now? Yes. And fun with a Wi-Fi setup. So till now, what we have seen, it is like a command line based. We have not seen the graphical, how it will be visible Raspberry Pi, and how it actually give the user interface. So we have seen once if it is in command line, how it can be configured for a desktop environment, how it can be enable camera and all. So now first we'll see how to configure for a Wi-Fi setup. So first part, as I told before, just we will power it up, our Raspberry Pi boot. So once it got boot up, so we will give the credentials Pi and Raspberry Pi is the password. Now the next command in a command line is be like in start X. So we have to type the command like in start X. Once we provide the start X, so it will come up with a graphical interface that is an Raspbian desktop. This is the desktop environment. So Raspberry Pi desktop environment, once it got boot up, it will be visible like this. Previously till now what we have seen, it is like a completely command line environment. So since we have made configuration for an desktop environment, we will come up with a desktop environment. On desktop environment, so we will get so many options. So on menu bar, we can see on the top the menu bar will be there. So in menu bar, and also this is a browser, directories, this is a terminal. I can open a terminal, some games. So this is the different options. This terminal is called as an LX terminal. We call on topmost the menu bar by default it will be there. So right now we are looking into how to perform a Wi-Fi setup. So once I press this LX terminal, my terminal screen will come up, will pop up. So click on the LX terminal button that is on the top menu bar. So on the top left menu bar, and start to type the comments. If config. So if config will give the complete information about your PC. So it will be consisting in a WLAN driver. So WLAN 0 is the driver. So to enable that one, once we give an if configurations, what are all the configurations, what are all the wireless configurations are there. So WLAN 0 as an USB interface, any Wi-Fi interface, it will give and all the options. So once we open a terminal, and if we give if configuration, if config is the command, so we will see an option like this WLAN 0. So WLAN 0 will be in that specific list. You can close the terminal by typing exit. So if I don't want the terminal, just we can type like an exit by pressing and then pressing an enter. So now WLAN 0 will give me the confirmation that wireless local area network interface is there in my PC. Now I want to configure it. So let's, for a configuration, we'll go to the menu bar. So click on the menu button on the preference. In the menu bar, we are having a lot of options. One is like a program. By Python is an programming language utilized in Raspberry Pi. In case of an Arduino, it is in C programming. We can perform in this also C, but very well supported for Linux, like the runtime environment based programming language is Python. So Python will support, and even for the development also it's very fast in Python. Even though it consumes more space, that's fine. So we have a lot of space in the GB level. We have a lot of space in our Raspberry Pi, but not in case of a microcontroller Arduino.
Internet, this is our browser. Some games by default, games will also be there on Raspberry Pi, accessories, help, preferences. So in these preferences, we will get in all the configuration part. So in the in the right hand side, we can see we are going to the menu bar and we are selecting a preferences, and in the preferences we are looking into then audio jack control, keyboard, mouse setting, monitor setting, means similar as like in our PC how we will do, and we'll get a window setting and a Wi-Fi configuration. So this Wi-Fi configuration will come up with a similar as like in our PC to 000 to scan what are all the available access points. The Wi-Fi access points we will call actually Wi-Fi network which is available in our home will call as an access points. So what this Raspberry Pi will do is, so Raspberry Pi once we select the Wi-Fi configuration, so we will come up with this kind of a GUI interface where we can scan the available network. So in my home, I want to scan what are all the available, the list of available Wi-Fi networks. So if I press on the scan button, it will give me the list of all the available Wi-Fi networks. Links is home and maybe D-Link and TP-Link, ASUS, different kind of routers, RB, Netgear. So it will provide all the list of different kind of routers and with a signal strength, and it will tell the frequency, which frequency, as I told, Raspberry Pi 3 will support for an 2.4 gigahertz as well as an 5 gigahertz, means 802.11 AC. AC will support for dual band. And the MAC address of the specific router, BSSID, and then SSID is the name, router access point name. These are all the router SSID, router access point name, BSSID, the address, MAC address, frequency, which frequency is supporting, and the signal strength for each router. What is the signal strength of the links is for my Raspberry Pi? So it will be visible. Now I'm able to scan. So after scanning, I want to choose the select a specific one for which one I have to add. Now click on the add button. So in this part, as like an ND guest, whatever the name we can provide it, and then without making any changes in the guest part. So no need to make any changes. Like a PSK means pre-shared key, encryption, authentication. So no need to make any changes. So I'm just choosing the one access point here, and then I'm going to an add. So in Raspberry Pi, there's one more option. So if I want to connect to any specific router, what I will do, I will give an SSID and then I will give a password. So without giving an SSID and a password, we can connect by making use of a standard card as a WPS. So we are support, means Raspberry Pi support for a WPS also. This WPS stands for Wi-Fi protected setup. So Wi-Fi protected setup means it is a wireless network security standard that will, once you press an WPS here, means this WPS button here, and in each and every router there will be a WPS button nowadays. Even in our mobile device also there will be a WPS. So if we press an WPS, that will perform Wi-Fi protected setup. It is just wireless network security standard that tries to make connection between the router and the wireless device. It will be very fast and it will be a secure process. No need to share our Wi-Fi password with anyone if it is a WPS process. So okay, without making any changes, we are in the process of a Wi-Fi configuration. Without making any changes, just give an add option. Once we provide an add option, so we will come up with adapter name, double LAN, and the network for which network I'm connecting to an ND neighbor guest, ND guest. So after that one, just click on the connect. So once if I click on the connect, so make sure that we have selected the proper network and click on the connect button. So once you click on the connect button, so in our main screen, home screen, we have an Wi-Fi connection should be now be working, means this symbol, this icon will come up. So this icon will represent the Wi-Fi configuration tool will be running in the background, and we will see this on the right corner. right top corner of our home screen. So these are the steps to configure and Wi-Fi part on our Raspberry Pi. I hope till now it's good, able to understand. Okay, I'm moving on with the command line interface. Command line. So because I once this is not an Microsoft or Windows OS or anything. We can make use of an Windows OS also for an operating system like an Windows operating system for a Raspberry Pi. That Windows 10 operating system is supported for an IoT core by an Windows. But Linux is like a very lightweight operating system. So it is very good to get started with an Linux operating system for a device like a Raspberry Pi. It depends on what kind of an application are we using. If I have a lot of an memory space usage and I want to make use of an some of the Windows applications I need to install, at that time Windows operating system is pretty good. So coming back with command line interface. Hands-on with a command line, the command line gives you more control. Means, as I told, we are in a desktop environment. On desktop environment, the top left part, in the top left, we will have an LX terminal. So LX terminal on top bottom, once you click on that, the terminal screen will pop up. That's terminal GUI. So on that terminal GUI, we can perform operations like multiple things. We can create a folder. We can delete a directory, we can create a file, we can create a Python file, and we can write a program. So LX terminal is for an direct LX terminal is for a terminal, and the very next one is like we are going through the command line lessons. Yes, to tell you what are how to make use of the command line interface part, and the very next to the terminal there is a file manager. As I told you, the directory, the file manager. The file manager will be consisting like in desktop downloads, old config files, and Python games. By default, in a menu bar, we'll get some games. So for that, the Python games. So the command lines in this one, the first different command lines we want to know is Raspberry config. We already used that one. Statex and if config. So Raspberry configurations, just to make all the configuration settings of an Raspberry Pi, we have already used it till now. And the statex is the one, and the if configuration is the one. While configuration of a Wi-Fi, we have used the if config. So basic other commands like these three commands we have used the mainly utilized for an configuration purpose. This is like if you know Python very well, no need to dig into more into this. It is like a simple. If I give echo will be print the argument on the console. So echo hello world. It is like a part of a programming. Echo hello world. It will just print there itself. It is like a simple, as I told you, support for an Python programming language. And the next one is like a man echo. Man will show the manual page of the argument, and press Q on the keyboard to exit the manual page. Most of the page screens, if it is open, by pressing the Q button on the keyboard, it will get exit. Next one is an apropos is used to search the manual page description. So if I want to search anything specifically, then I can make use of an apropos used for to search the manual page description for the specified keyboard, and you can find commands with copy in the description of it. Okay, in the right side we can see the description of an each and everything. What all the commands are there for specifically with an string copy, objective copy, and memory copy. So all these things, what all they're available, copy memory area, copying a string, and copying a fixed size string. So what all the commands are there? So all those things can be searched. This is like an help command. I want to clear my screen. So this is a simple command like an clear. So if I type clear on my screen, it will make your screen neat. If so many things will be there, so once I press clear on my screen, it will clean your screen.
PWD, it will print the working directory path. For example, if I am there in so many different files inside of one more directory, inside of another directory and all, at that time, so PWD will print the current directory path where I am sitting, means the what is the location, so will be printed on the screen. So here if I give PWD, it will tell me the directory path, like where it is present. It is an home and pi. In the pi directory, at present my work access point is located. LS, list of the directories in the current working. These are the Linux basic commands. What are all the basic, what are all the list of the directories or the files are available will be listed on the terminal. Arduino and Raspberry Pi, in these two things, Arduino is a good thing to get started with. But while you are going with a product development, or else while you are going with any specific, it may be a smart home, or else it may be a smart industries product development. So it is not like a directly using its Arduino board. So it is like a proof of concept. To develop a proof of concept, the board is pretty good, and the chips what we are using. So instead of that, was so many controllers, so many devices are there, like an Texas Instrument, Atmel, and microchip, and STM32. So these are different controllers are there. Silicon Labs is providing silicon chips, and these are the different. Actually, if we go with a manufacturing unit, means as a product based, even where we are working on Arduino, I suggest only for a POC to get started to learn an IoT. What is an IoT? How to get started? For an actual product development, my suggestion to go with an other microcontrollers, high-end processing microcontrollers are available. For example, even these microcontroller manufacturing companies like TI, Texas Instruments, Atmel, STM, or any other, they are all providing completely coming with a stack. So we have a stack like an Zigbee. So we have a stack for a Z-Wave, we have a stack for an LoRa, we have a stack for an LoRa is from Simtech. So we have to make use of a Simtech chip. So these are the some pretty end, and once we come to an IoT, so in that case we need some simulators also. So yes, I am building one mesh. If it's a mesh technology, I suggest to go to some simulators also, because I am developing a product, and if I develop two modules, like two or three modules, those 2-3 modules can communicate very well. But if I'm going with an like 80 to 100 modules in a mesh topology, because it is an Wi-Fi, it is completely an IoT based mesh technology, we are not able to test that one. In practically testing, it takes a lot of time. So we have to choose some simulators. What kind of products we are targeting, and based on the product and what kind of a wireless communication, means wireless protocols we are targeting, and this is it a mesh topology or is an end-to-end single devices. So based on all that, we have to choose the module, and also we have to choose if it is a simulator is required, and to wireless. Is it a battery operatable, or else if it is a directly power supply connected device? So these things we have to choose. And as I told, Arduino is good to get started with, to understand what is an Internet of Things. And Arduino, for example, Arduino, how much the power consumption? So compared to Arduino, is there any other microcontrollers in market? So many microcontrollers are there, SoCs are there, so which can provide very less power consumption, and which can increase the battery lifetime. And also those microcontrollers are already supported with number of stack. So means even while choosing anything, how the manufacturing units will choose means one microcontroller, and I must be seamlessly, I must be able to use multiple different communications. It may be a 6LoWPAN, or it may be a Zigbee, or it may be Bluetooth, or it may be a Wi-Fi. So single microcontroller, because at the time of production, once the chip designing, because for product we won't use the Arduino how it is available. Arduino is that directly we can't use, because the compact size of the device, or power consumption, so many other interfacing peripherals will be there. Though all the peripherals will be consuming power. So at the final product, we don't want all those peripherals. So we will be having our own customized board circuit design. We will be having our own customized circuit with our required interfacing sensors or actuators.
So, so the thing is like, in case of a Raspberry Pi, that is like a gateway. Yes, what we will learn with a Raspberry Pi, we can seamlessly use it as a gateway. So many other high-end processors are there. Even it's a Broadcom chip, what it is supporting. In the same way, so many high-end processors like an Panda board, Beagle board. So these are all the boards are supporting as a gateway. Yes. So Raspberry Pi, I suggest to, yeah, you can go with an as a gateway device for an high-end processing. Raspberry Pi is pretty good, and so many products are coming up. Means Raspberry Pi, some customization they are going to do, not to use directly as it is Raspberry Pi. If I place inside my box and if I cover it up the Raspberry Pi, and if the end user, just if you break that one, you can see the Raspberry Pi directly. It is not an actual product look like. The actual product will be customized design will be there. So even in the case of microcontroller also, Arduino board we can't use directly. We are going to the chip which is already there with all the multiple interfaces. So how can I utilize those interfaces in a proof of concept? The Arduino is very good. Just like in why Netduino .NET is required. So C is there. C is the pretty well supportive programming language. But it's an estimated by 2020 there will be a tens of billions of an device connected to the internet. But as a .NET developer, devices like Netduino provide a low barrier to entry for IoT utilization. So actually, frankly, this is the only one platform which supporting an C#, that's a .NET platform for the development for an IoT. This will be an introducing IoT using Visual Studio and Netduino. Already I have mentioned little bit part about what it is and Netduino and all. So we'll see what and why this is required and Netduino and the platform hardware peripherals required for this and some of the configuration process. Because Netduino here we need micro framework, and it is not like directly to get started with an Visual Studio. Some steps has to be followed on Visual Studio. So after that we can get started with some of the examples. So here the main choice of a Netduino is .NET framework, and this Netduino board will support for an with an Ethernet port as well as Wi-Fi. So it will easy to connect with an internet, and also we can build multiple applications by making use of a Netduino board. General gear. So what are all there in Netduino? This is based on Netduino Plus microcontroller board. So that board will be consisting an 48 megahertz Atmel SAM7 microcontroller. You can see the RAM size and the flash memory size is very good, like an 128 KB of RAM and 512 KB of an flash memory. It is pretty good for an embedded end devices. So this device having an peripherals like an USB, Ethernet, 20 digital input output pins. 20 means we can assume how many sensors we can connect, and 6 of them which are configured as an analog input. The onboard we will get SD card slot. If there is no backhaul connection, if there is no backhaul internet connection, I can store the data. Because if I am going to with some Arduino, in Arduino we won't get that support. If I want to capture some image and if I want to store it on my controller, if there is no backhaul connection, so that will be very challenging part. So in case of a Netduino, we can capture the image, we can store. Even though if the sensor data is more, I don't have a backhaul connection, there is a loss in connectivity, I can store the data locally in SD card. So onboard LED push button, this is for an kickstart, and some of the form factors like in many Arduino add-on boards are available, even in Amazon, as well as it is available in a Sparkfun. It is completely into a .NET micro framework, programmable into a flash memory, and we'll look into how to include a .NET framework and all. This is a very pretty updated one, Netduino 3. So if you wanted to start with if you specifically into a Netduino, I suggest to go with a Netduino 3 since it is on Wi-Fi, because wireless is the preferable one. So Netduino 3, we can see here what are all there. It is consisting an Wi-Fi chip. It won't support an Ethernet port. It won't support an Ethernet port. It directly only we can make use of an Wi-Fi. So it consisting in I2C power and 14 digital input points and 6 analog pins. So in total 20 input output pins, and we are getting a power supply with an 5 volts input and micro USB cable, SD card slot, and also Go bus ports. These Go bus ports are for interfacing in different modules like an add-on boards, maybe display. We can connect a display also, 7-segment display, LCD display, and all. We can multiple things to connect. These are all the Go bus ports. So send input output serial Go bus, and with that one power voltage is like 3.3 volts and 5 volts, and it will be consisting an USB as well as DC jack, and features Wi-Fi or Ethernet depending upon the model. In 3 only Wi-Fi, and below of that it is an Ethernet, button, LED, USB, micro SD cards. In digital input pins, we will get, if this depends upon the sensor, we will get an SPI, serial peripheral interface protocol, UART, pulse width modulation, because if I want to control, pulse width modulation is very important. In some of the Texas Instruments, you want to make use of an additional chip. So in the pulse width modulation, if I want to control a smart home, and if I want to control the speed of a fan regulator, or else if I want to control brightness of my bulb, so those all, it depends upon the, if I want to control the speed of some motor, so it depends upon the pulse width modulation. I2C, Go bus, Arduino's I2C bus is also supported. So here it mentions clearly that it will support for an Arduino based additional add-ons boards also to communicate with. Analog input output pins reads the value from 0 to 1024 maximum and 10 bits. So which are all the pins? So we got to know that so many pins are there. It will support multiple things, parameters. Which are all the pins for what? Digital input output pins means all 22 digital and analog pins in that one. 0 and 1 for an UART RX, and so digital, I'm just pointing specifically to the pins number. So 0 will start from the bottom. So among the 14 pins, so this is the 0, 1, digital 0 as well as 1. It will support with an UART RX and TX. This UART RX and TX will be utilized to program, I mean the flash the microcontroller also. So we can, if I don't want a micro USB cable, because once I go with an mass production as a product, so these are the additional peripherals. I don't want to keep a power port. I don't want to keep a micro USB port. I don't want to keep some additional GPU pins. I don't want. At the time to program my microcontroller, I can make use of an UART RX TX pin. 0, 1 and 2, 3 will be my UART RX TX and pulse width modulation. 5 to 6 pins that are all GPU input pin also as well as output pin, and also those pins can be utilized for pulse width modulation. And the pin number 7 and 8. So we can see again 7 and 8 will support for UART RxTX, also work as an RTS and CTS clock. And digital 9 and 10 will be for an pulse width modulation, and 11 to 13 for MOSI, MISO, that is for specifically for an SPA protocol. The last ST and SCL, that is for a data and clock line. So I2C protocol will be utilized. From where all this we will get accessories, because this Netduino and the design based on that one, I want multiple sensors, I want multiple add-on boards. So all the material, all the things we can get it from Amazon itself. I just searched. So in that one also we will get Arduino Uno 3 Mega, ADASUS, Nano, and also Netduino also we will get, and also all kind of an additional kit like in transistors and resistors, some of the sensor modules, some of the actuators, and also some of the display modules, everything, capacitors for the circuit creation, breadboard, all the materials are available in on Amazon. So I recommend to just go and get it from there. I'm just moving to the software part. .NET framework will be used, that is in Visual Studio templates and device drivers. So for an building and circuit, we are making use of a breadboard and PCB board design. This fritzing means it is a tool to create a circuit. For example, some circuits I will show that there is a pin diagram connection, how it is between, for example, LED and the microcontroller, how is the connection has performed. So that kind of an design will be done by making use of this fritzing tool. So it is easy, just drag and drop kind. Okay, let's start how to get start with an on .NET micro framework. What are all the steps to be followed to start with an Netduino board? We'll look into that one. So this is a Visual Studio framework. So in this Visual Studio, we will get an extension. So once we just get start with, so in this part we have to make use of an Visual Studio .NET micro framework like version 4.3.2 and Netduino SDK. These two we need to install in our Visual Studio. So Visual Studio version is like in 2015. So we can commonly we will use Visual Studio 2015. In addition with that one, we need two things, that is like an .NET micro framework, that is an .NET MF version 4.3.2 and Netduino SDK. So once we launch the Visual Studio and we have to click on the extensions, that extensions on the menu bar. This will open up the extension manager window. So we have to specifically type the micro framework and search in the inbox, and we should see the one result. That is like an micro framework, and we have to select that one. Yes, in the right side we can see here we have to select the micro framework extension and we have to install. So by making use of an install button, it will actually promote us within a dialog to start with the micro framework, that is within version 1.0.3. After once we install it, so we can go ahead and next. Yeah, so once after that one, so we can go ahead with choosing a console application in a micro framework. So we have to choose a micro framework and then console application. That is like in Visual Studio 2015. If we go to a file and click on the new project, once you click on the new project, you will look into the micro framework category. Once you select a micro framework category in the template section. So in this template section, once you select a micro framework category, you will get these options. In these options, you can select a console application. So once we can select a console application, we have to give the program name. What is the my program name? For example, it is like a Blinky. So means LED blinking process. So we can give Blinky, and then once after this project is created, we need to ensure that targeting the .NET micro framework, because there are multiple versions are available. So this, as I mentioned, it will support with an .NET micro framework version 4.3 in a Netduino board. We have to make sure that. So once we get started with the project, we have to select the .NET micro framework version 4.3 in the specific solution explorer. Sorry, yeah. Next, the last part is to choose the interface part. That is like a BlinkView project. So in a development transport, we have to drop down and menu select. We have to select an USB for a programming process, and our .NET device should be detected automatically. Once we select, if we have connected our Netduino board to our PC, once we select this development in part of a development transport drop down menu. So once we select an USB, the tool, that is a Visual Studio tool, has to automatically detect our Netduino board. So which version will be shown in that? This is specifically in an Mac OS. I'm just skipping this one. Okay. Putting all in together, so temperature sensor and LCD. So putting it all together means once after all this configuration setup in an Visual Studio, so we are going to write in some small example. So it may be like a temperature sensor and displaying the sensor data and LCD part. So here I've given one YouTube link also how to just blink or how it will work. So this is the Fritzing. Fritzing, as I told you, this is a tool which helps us to create this kind of a circuit diagram. So similar like an Arduino board. In Arduino board, how we have interfaced, this is one temperature sensor, and just connect your display, that is a segment display, and
get the temperature data when there is a change in a temperature data, get the data in our display. The same process is performed here, but in addition, I added one switch as well as one thermostat. Actual implementation will look like this. So in Fahrenheit, when there is a temperature, as I told, that the temperature sensor is an LM35 temperature sensor. When there is change in temperature sensor in real time, it will be displayed like in Fahrenheit this much, like in 66.09. If you want, we can convert it to an degree Celsius also. That is all depends upon the programming part. And the Netduino board, which is used here, is, as I told, it's a Netduino 3, and we can see it once we are able to read the data, we can push the data now to the cloud by making use of an Wi-Fi based communication. So this is the programming part. So programming, .NET programming part, I'm just not going through this one. Architecture of the HelloPachube. The PACHUBE, what is the PACHUBE? Already we know that the things speak. So PACHUBE, now it is called as, it is like a Google based cloud. I will discuss in detail about an PACHUBE, how it will be work. So to get started with a Netduino, I suggest to, instead of a ThinkSpeak actually it won't, as I've seen, it won't support, it's not a concentrator, it won't support the interfacing with the, or as collecting the data from the Netduino board. Means there is no get started examples. But for this PACHUBE, so for this cloud, that is like an PACHUBE, or else we can also call it as like an Xylee. Xylee is also another the recent name. So Xylee is also known as an COSM or as PACHUBE. Previously, this cloud is called as an COSM or PACHUBE. At present, it is called as an Xylee. So in most of the documents for a Netduino, it is used as a wording called as an PACHUBE. So PACHUBE is why I am suggesting here is it is going to give an idea to easily to get started. Some of the examples are available to get started with the PACHUBE platform. So there is like an one of once we get the data like from thermostat, so we will get an analog data on our controller, that is Netduino board. We can perform analog to digital conversion. Once the analog to digital conversion is done, so we can push the data directly to the cloud. So that is a PACHUBE cloud. And the same data will be collected in the client devices, that is like maybe end devices using a web server, so web application or as a mobile application. So we look into that what is actually PACHUBE and what are all the features it will provide. So in this process, so in a Netduino, while making use of the complete architecture, how it will be there like. So consider this local area network is my Wi-Fi router. So this LAN is my Wi-Fi router, and this is my Netduino board, the left hand side, and the right hand side is my PC. I can connect an USB cable in between my Netduino and my PC to program it. So I can program it in two ways. So where it can, the data will go to all the way to the cloud, that is like a DNS server, that's an internet, and it comes back to my PC. Or else, if I won't assign any IP address, if I don't assign any PACHUBE or ThinkSpeak kind of cloud, so then it will be local communication. In case of a local communication, so my router will means the Wi-Fi router, there is a LAN which is running a network address translator and dynamic host configuration protocol server. So this Wi-Fi router will assign one IP address to my Netduino board. So because once you assign an IP address, this device, this Netduino device is part of my network. It is like similar to my mobile phone. Now my Netduino board can push data to the laptop or desktop or as to mobile phone, which is there inside my home, inside my network. For example, if my AC air conditioner is connected to my Wi-Fi router, if it is an Wi-Fi based, or else an Wi-Fi based some bulb, IoT bulbs are there. So this Netduino will be consisting some IR detector, IR sensor. If there is any movement, if there is any direction, automatically it will push the data to the Wi-Fi router. Wi-Fi router will push the data to the cloud, means to the bulb, which is the end device connected. Means we can build easily, by making use of a Netduino board, the local communication network. And if it is required, if based upon the design, we can push all the data to all the way to the internet, that's the cloud, and from the internet we can access the data. Some of the references I would like to show, just you can take screenshot or some. Okay, so these are some links based on the blog. I have some with respect to the Netduino, where it all supports, and some of the interface internet serial peripheral interface, because SPI programming while performing how to, because it depends upon sensor. If analog and digital directly we will get from the library, so we can utilize it, and SPI we have to program some protocol. So SPI protocol for that configurations has to be done. So we have to look into that part. So some of the Wikipedia asynchronous reception and transmission, that's for an UART, how it will be done. So some of the technologies, they have some how to basic implementation design have advertised or as posted on website. Okay, I mentioned the PACHUBE. I would like to tell about what is PACHUBE, as PACHUBE, and what actually the platform will provide. We'll look into this one. So if you search for an PACHUBE, you won't get in more data or as details, because at presently that cloud is called as an Xively. Xively is an Internet of Things platform owned by Google. So this is formerly called as an COS or as an PACHUBE for an Internet of Things platform. Now right now it is owned by Google, and this Xively, or as a PACHUBE, Xively I will call. Xively offers product companies a way to connect products, manage connected devices and the data they produce, and integrate the data into other systems will be supported. It's not like an Xively. The pronunciation is like an Xively. This platform Xively what it will provide is like since why network device and environments, like in remote monitoring and control, connected interactions and the social relationship. Multiple products will be there. So for that, the services, recurring revenue, and new business model. As I mentioned, business model is completely depends on the data and how we will utilize the data. Real-time product analytics, unique in market, and network many-to-many and cross-domain benefits and efficiencies. Both making data public and public making data. Third-party extensibility means supporting the third-party platform. So this Xively cloud service, when we look into this cloud service, the platform is a service built for specifically for an IoT. According to that Xively, so this is like one of the trust engine for security and web-based management applications. And also in the Xively message is built in for a publish subscribe method protocol, like MQTT, you may add message queue telemetry transfer. That is completely depends as like a published subscriber. So there is one protocol called CoAP, Constant Application Protocol. That is depends upon request and response. This Xively messaging is built on a published subscriber protocol. That is this completely built on standard cards on MQTT protocol based. And this API calls what all is there. It will support for an REST architecture, representational state architecture. It will support for WebSockets. It will support for an MQTT and all. And this one Xively as is one of the partnered with an chipset companies like an ARM, Atmel, and Texas Instrument. So officially they will support with an ARM design and also Atmel design and TI design with a complete library for those microcontrollers, and it's easy to get started integration, implementation process and all. What is a PACHUBE is? So as I told, so PACHUBE for devices and environment. So what is PACHUBE? Hub, the word means hub is the one which can collect the data from multiple platforms. So in this case, PACHUBE for devices and environments. So what are the devices? It may be microcontrollers and sensors, and building management system, mobile object and vehicles, or as variables, or environmental pollution, virtual environments, or automation system. So here we can see
It is some more related to an industry-based products. Also, it is some related to a consumer-based product. So PACHUBE will support the complete platform to collect the data, to store the data in specific API. This API, what are all the APIs set will support for an IoT platform? It enables both storing the data, sharing data, context data, support multiple protocols and adapters. So multiple protocols, it means, as I mentioned, it will support for an REST architecture, WebSockets, MQTT, even CoAP also it is supported. Provide rich user extensible and metadata. More than that, delivers an scalable, resilient, always on services. Yeah, so the main key market for this one, energy, that is smart meters, like collecting the data analysis and load balancing, reduce total capacity investment and all, building and home automation, industrial process monitoring, sensor networks, transportation, there is a localization, means when there is a mobility in a network, and also healthcare. So some of the challenges are there, like in scalability, interoperability. We have already discussed these points. I'm just picking up the points because the cloud, what all it will support. Scalability, interoperability, managementing of an web-based tool and control and visualize performance, openness, ease of adoption, and security, control that are flexible and robust, because end-to-end security. These are all some of the challenges with respect to the IoT. This PACHUBE will provide an scalability for M2M data that is increasing exponentially, as well as interoperability. It will provide across all the devices. Means some of the devices are 6LoWPAN based, some of the devices are Wi-Fi based, some of the devices are thread-based communication. So for all the devices and all the different programming languages, like a major programming languages, this platform, this PACHUBE cloud will provide an interoperability among those. Management. So once management via web-based tool is control and visualizable, it is easy. In just the next slide, we will see how it is for managing the web-based tool and also for a mobile application development also. Performance, like throughput and latency. End-to-end scenario, latency, if you go for any product, that will come in matter, because even multiple networks will be there. They will be running their proxy server, or else they will be running their server in some other country. The request has to go all the way from somewhere and it has to come back, the response has to come back. For example, if I switch off the light in my mobile phone, the end user or as a customer expectation is to, it has to get switch off within a second at the time itself. So if it get delayed like in 2 seconds, if the user sees some latency like in 2 seconds or 3 seconds, then most customers won't like that product, because latency we have to concentrate more from end-to-end deployment, end-to-end scenario deployment, product development perspective. Redundancy architecture with an high availability, and openness for ease and adaptation of industry acceptance. That is a standard-based API called simple and quick. That is like in just plug and play. Directly it has to support all the standardization. Security, HTTPS, SSL, powerful permission and authentication management, onboarding process, secured onboarding process, cloud security process, means data storage security process will all be supported. Means this is like an hybrid cloud. So this is like also called as like a multi-cloud. So however, this will support like in multiple platforms. The core application is like, we can see multiple applications are there. So store, share, monitor, privacy options, is history API call, statistics API call, and extended search, complete history, means what are all the data. For example, in as I remember, in case of ThinkSpeak, we were discussing, we got a doubt that can we get a data of one, like in 15 days old data. Yes, in this case, I'm sure this tool PACHUBE will provide the complete data. And one thing I'll make sure, it is not completely free. We have to pay. For example, this one, AWS. AWS will tell in the beginning they are free. Same way, it's like if you go with a credit card registration, 1 year free, the AWS. But it is not completely, it's not. So only, for example, Lambda is the tool which will be used for an IoT purpose in AWS. So they won't provide it completely free. Few API calls, you can't, you just
like a place some of the options, we can't utilize the complete which is required for a product development. So store and share, monitor, trigger, and notifications means automatically the cloud. In a cloud we can perform configuration. For example, my pH sensor value means acidic content is going high. Give the notifications. Give the trigger some, or else trigger some operation means add a base solution to neutralize the liquid. Or else graphs and visualization. These three upper part is responsible for an user to visualization part. Graphs and visualization for analysis, it will make easy. Privacy options, history API call, retrospective updates, and statistics API call, extended search. So these are the API calls which is support for a history API call, statistics API call. So where I can get the complete data based on my web development, I can utilize these API call for my own customized application development. Complete history, as we want, I want some like 2 months back data. I want like some old like after old 6 months data. I can collect all the data. I can see the complete history. And security, global triggers, volume API access. I may need multiple. I can create my own API calls, also customized API calls. Some of the standard API calls. Even if I want some my own customized API calls, I can develop user management, branded gateways, commercial deployment, and division provisioning. Provision means each and every device, which is an IoT device. It's not allowed to connect any device and push the data to the cloud. So cloud must, it's like a gateway. Cloud must will be like having its own security. It has to authenticate which device is sending the data. Either I need to collect this data or not. All this, because if someone is, if someone got my API call and if he started pushing the data, simply means just a garbage data. So one day, just within a day, you can fill all my storage space. So I will come with an it will get overload. My storage space will go overload. So we have to avoid within security. So device provisioning. This patcher will provide all this specific. So Ruby on Rails and PostgreSQL DBMS hosted with an Rack Cloud, it's supported, and also functionalities like an environment. Yeah, this one where the location, even this geolocation is be identified based upon the in the ThinkSpeak also. So functionalities like an users, environments, data stream, data points. So RESTful interfaces like an by XML, JSON, CSV kind of and responses. So this is for an communication. JSON format will be used for communication. So for the development purpose in perspective, and some of the parameter we already discussed this. And device provisioning server means, as I discussed, registry device feeds users in factory, managing device deployment. All this can be handled from the cloud. All this can be optimized and customized, and we can utilize this for our based on our product requirement. These are some examples of an Apache or as a Apache blog or some of the implementations that are available. So we can just a screenshot of those. We can see where the data is node or as a device is placed, or else we can collect the data, how the graphical representation will come.
That is it. We hope you liked the content. If you liked it, please be sure to give us a like. Thank you and goodbye from Intellipaat.